Welcome to my course Elasticsearch 101, a beginner's guide to Elasticstack. This is a hands-on course with focus on deployment and management of Elasticstack. My name is Vikas Yadav and I am a senior solutions architect with over 15 years of experience in IT, and I'm currently working at a multinational company where I have designed and deployed Elasticstack in a production environment. I have taught more than 3,400 students on Udemy and have an average rating of 4.4 across all my courses. This is a hands-on course with focus on practical learning. In this course, you will deploy Elasticstack and then add some data to your cluster through different methods such as logstash and kibana integrations, and also you will transform that data in order to extract some meaning out of it. Finally, you will deploy Elastic Agent to easily extract metrics and log data from your application servers and store and analyze that data in Elasticsearch. So please join me on this journey to learn Elasticstack. Hey guys, there are different type of databases that you will come across and each offers its own unique benefits. These can be primarily categorized into SQL or relational databases and NoSQL or non-relational databases. First off, let's have a look at a relational database. A relational database is a type of database that stores data in tables. In a relational database, each row in the table is a record with a unique ID called the key. The columns of the table hold attributes of the data, and each record usually has a value for each attribute, making it easy to establish relationships among data points, and hence the name Relational Database Management System or RDBMS. This type of database can only work on structured data, and structured programming languages such as SQL can be effectively used to insert, search, update, or delete database records. Some common examples of RDBMS are Oracle, MySQL, Microsoft SQL Server, and PostgreSQL. Now, here is an example of what a relational database looks like. Let's say you have a table that stores users' details, and let's say this table is called users. Now, this users table will have details such as user ID, first name of the user, last name of the user, and their age. Now let's also say that there is another table that stores user's educational degree, and it can be related to the users table by using the user ID column. As you can see, this type of data is structured and is stored in tables, and it can be related to each other using columns such as the user ID column in this example. Now let's talk about non-relational databases. A non-relational database is a database that works on semi-structured or unstructured data. It is also called a NoSQL database and has a dynamic schema for unstructured data storage. This data can be stored in many ways, which means it can be document oriented, column oriented, graph based, or a key value store. This flexibility means that the database can be created without having a defined structure first. Now, if you compare this with relational databases, you always need to predefine the structure and adhere to that structure throughout the life of the database. Next, NoSQL databases store data in documents which consist of key value pairs. The syntax varies from database to database, and you can add fields as you go. NoSQL databases provide flexible data model with the ability to easily store and combine data of any structure without the need to modify the schema, and hence it is suitable for big data and real-time web apps. Elasticsearch is a type of NoSQL database that stores data as a JSON document. I've attached a link from Elasticsearch's blog if you want to read further on this. Now let's have a look at an example of a NoSQL database. Here on the screen, I have a NoSQL database that consists of two documents. And as you can see, the structure of both documents differ. For example, document number 2 has a key value pair for education, which is not present in document number 1. Also, if you look at hobbies, there's an extra hobby of swimming for our user. Now, this flexibility allows NoSQL databases to be used for big data applications. Now, there's another difference between NoSQL and SQL databases, which is how they scale. Relational databases scale vertically, and NoSQL or non-relational databases scale horizontally. What that means is when you have to increase the capacity of your database, the only way to do it in a relational database model is to have a bigger machine. Now, what this means is downtime to increase the capacity and maintenance task. A way to avoid having a downtime later is to pre-provision capacity. However, the flip side of that is that all that capacity would essentially be wasted until it is needed. Non-relational or NoSQL databases solve this problem by horizontally scaling. What that means is that whenever you need capacity, you can add more capacity by just adding more machines to your cluster. This way, you do not have to pre-provision any capacity and you do not need downtimes as well. With this, we've come to the end of this lecture. Thank you for watching and I will see you in the next one. Bye.
Before we start the deployment, I would like to give you a brief overview of each of these Elasticsearch products that we will deploy in this lab. Elasticsearch is an open source RESTful distributed search and analytics engine built upon Apache Lucene. Logstash is an open source server-side data processing pipeline that ingests data from a number of sources, transforms it, and then sends it to Elasticsearch. Kibana is an open source data visualization dashboard for Elasticsearch. In simple words, let's say you have application log data from application servers. Now, in case you do not need to do any processing on that data, you can send it to Elasticsearch directly to be stored and indexed. However, if you do need to do some custom processing, for example, you might need to add a customer ID to a log event so that you can tie a particular log event to a particular customer. You will first have to send that data to Logstash, do the processing or transformation, and then send it to Elasticsearch to be stored. Once the data is stored and indexed in Elasticsearch, you can use Kibana to create some visualizations on top of that data. Now let's talk about beats. Beats are essentially lightweight purpose-built agents that acquire data and then feed it to Elasticsearch. Beats are built upon libbeat framework and it makes it easy to create customized beats for any type of data that you'd like to send to Elasticsearch. So beats have standard beats that are available, which I've listed on screen. If one of these beats does not do the job, you can use the libbeat framework to create your customized beat. So let's talk about some of the standard beats. First, let's talk about Filebeat. Filebeat is a lightweight shipper for forwarding and centralizing log data. Installed as an agent on the target server, Filebeat monitors the log files or locations that you specify, collects log events and forwards them either to Elasticsearch or Logstash for indexing. Auditbeat is a lightweight shipper that you can install on your servers to audit the activities of users and processes on your system. For example, you can use Auditbeat to collect and centralize audit events from Linux Auditd framework. Metricbeat is a lightweight shipper that you can install on your servers to periodically collect metrics from the operating system and from services running on the server. Metricbeat takes the metrics and statistics it collects and ships the output to either Elasticsearch or Logstash. Heartbeat is a lightweight daemon that you install on a remote server to periodically check the status of your services and determine whether they are available. The difference between Metricbeat and Heartbeat is that Metricbeat only tells you if your servers are up or down, whereas Heartbeat tells you whether your services are available. So for example, let's say you've got Apache installed on a server. Metricbeat will tell you if the server is up or down. Heartbeat will actually tell you if your website is up or down. Packetbeat is a real-time packet analyzer that you can use with Elasticsearch to provide an application monitoring and performance analytics system. Packetbeat provides visibility of communication happening between the servers in your network. JournalBeat is a lightweight shipper for forwarding and centralizing log data from systemd journals. It is also installed as an agent on your servers and it monitors journal locations that you specify, collect log events, and then forwards these events to either Elasticsearch or Logstash. WinLogBeat ships Windows event logs to either Elasticsearch or Logstash. It is installed as a Windows service. FunctionBeat is an elastic beat that you deploy as a function in your serverless environment to collect data from cloud services and ship it to Elasticsearch. With this, we've come to the end of this lecture. Thank you for watching. I will see you in the next one. Bye.
Hey guys, in this lecture, let's set up our GCP account. As I have mentioned previously, GCP or Google Cloud Platform provides $300 in free credit that we will utilize to set up our lab. So let's get started. So here on my Chrome window, I'll type in console.cloud.google.com and then hit enter. This will take me to the administrative console for GCP. Now, if you've never used GCP before, you'll get a bar at the top that says your free trial is waiting, activate now to get $300 credit. Now on this bar, I'll click on the activate button on the right hand side
This will take me to the trial activation page. On the right hand side, there is some information about free trial and that they will not charge me unless I manually upgrade my account to a paid account. On the left hand side, first you'll need to verify the email address is correct. Then you can choose your country and then accept the terms of service and click on continue. On step 2, you'll need to put in your details such as if it is a business or individual account. My account is an individual account, so I'll select individual. Then you'll need to type in your name, address, phone number and credit card details. We'll make sure we stay within the free trial limits during this lab, and also we'll clean up everything after we are done with the lab so that there are no surprises for us. In the end, you can click on start my free trial to activate your trial account. I already have a trial account set up for this exercise, so I will move into my account. So this account's already set up, so I'll go to console.cloud.google.com. Once you've set up your trial account, you'll be at the home page of the default project which everyone gets initially, called My First Project. You can see this on top left right next to the Google Cloud Platform. We will create our project as part of this lab. However, before we move on, let me show you how you can check your billing charges, etc. so you can monitor how close you are to using your free trial balance. On the right hand side here, you'll see a card called billing. On that card, click on view detailed charges. This will take you to the billing dashboard. There is a lot of information here and you can do stuff like set up your budget and set up billing alerts, etc. But for now, click on overview from the left navigation menu. Now on this menu, towards the bottom right hand side, there is another card called free trial credit. On this card, you can see the amount of free trial credits that you've got left and also the number of days remaining for you to consume those trial credits. Remember, you've got those 300 US dollars trial credits for 365 days or 1 year. So with this, we've come to the end of this lecture. Thank you for watching. I will see you in the next one. If you like this video, please subscribe to our YouTube channel. Hey guys, let's start provisioning our GCP infrastructure from this lecture. We will create a new project, then we'll create a new VPC with 2 subnets, and we'll finish off the lecture by creating some firewall rules that allow access from outside world into our environment. So let's get started. Here, I'm in the administrative console. To create a new project, I will select the drop down next to the project name and then I'll click on create project. Here, I will name my new project. I want to name it Elasticsearch-demo. Then I'll click on create. Now, you'll see a little bell icon on top right that starts revolving. This means that GCP is doing whatever is necessary to set up the project at the backend. Once it's done, you'll see a green tick box that says this task has finished. Once you get that, you can click on it to go to the home page of the newly created project. Here, from top left, select the navigation menu and then go to VPC network. Now you might have to search for it a bit down under the header networking. If you have to do that, make sure you click on the little pin icon here so that it is moved to the favorites area up near the home button. Now once you do that, click on VPC networks inside VPC network and you might get a notification saying compute engine is getting ready. What this means is that GCP is setting up whatever necessary APIs that you need for this project in the back. We'll just have to wait for it to complete doing that. Once the compute engine API is ready, you'll see that you already have a VPC network called default set up for you. We will not use this VPC network, so we'll have to create a new VPC network. So click on create VPC network from here and let's name our VPC network. I want to call it Elasticsearch-VPC. Now under subnets, make sure that the subnet creation mode is set up as custom, and under new subnet, let's create our first subnet. Let's call it monitoring. For region, let's choose US West 1, because in my experience this is generally the cheapest region. Under IP address range, let's type in 192.168.1.0/24 and then click on done, and then click on add subnet to create the second subnet. For name, let's type in web servers. Region, again we'll just choose US West 1, and IP address range would be 192.168.2.0/24. We'll click on done and then click on create. This will create our VPC network. Now once this network is created, we'll go to default and delete this VPC network. So now you can see that the default VPC network has been deleted, and we have created our VPC network called Elasticsearch-VPC. So if we just look at the status, we'll see that GCP at the back is still finishing the creation of new network, and it's also deleting the default network. Once you get the green tick box, you'll see both subnets, monitoring and web servers with both IP address ranges 192.168.1.0 and 2.0. Then you can move on to firewall rules to set up our firewall rules. Here we'll click on create firewall rule to create the first firewall rule, and in this one let's allow SSH access into the environment. So allow SSH. Network, we have to make sure we select Elasticsearch-VPC. Under targets, we'll need to choose all instances in the network, and then under source filter, make sure IP ranges is selected, and then under source ranges, type in 0.0.0.0/0. Now under protocols and ports, choose specified protocols and ports, and then select TCP and type in 22. And then click on create to create our first firewall rules. Next, click on the create firewall rule button again. This time we will allow HTTP and ICMP access for our web servers. So let's call it allow HTTP-ICMP. Now select the network for Elasticsearch VPC, and under targets we'll need to keep the specified target tags, and here under target tags let's type in web servers, and under source filter we'll type in the range 0.0.0/0. Now under protocols and ports, we'll need to keep the specified protocols and ports selected, then select TCP and then type in 80 for HTTP access, and then choose other protocols and type in ICMP to allow ICMP access from anywhere outside. Now once this is created, we can click on create firewall rule again to create the third firewall rule. So let's name this one allow ELK, and this time we will allow access to the kibana URI. So under network, let's choose Elasticsearch VPC, or actually let's just name it allow kibana. Now under targets, say specified target tags, and under target tags let's choose kibana. Now under IP ranges, type in 0.0.0.0/0, and under protocols and ports, let's select the specified protocols and ports, select TCP and then type in 5601 and then click on create. Now click on create firewall rule again to create the fourth firewall rule. This will allow unrestricted access for internal communication. So this time we'll call it allow internal. Choose the network as Elasticsearch VPC. Under targets, change it to all instances in the network. Under source filter, select IP ranges and then 192.168.1.0/24, comma, and then type in the next IP range 192.168.2.0/24, which is our second subnet. Now under protocols and ports, select allow all and then click on create. Now this way we have created 4 firewall rules. One to allow unrestricted access for internal communication. The second rule to allow HTTP and ICMP ports for web servers from anywhere outside the environment. The third rule allows access to kibana port 5601 from anywhere outside the environment, and the target is the servers with tag kibana. And then the fourth rule allows SSH access from anywhere outside the environment. This rule seems a bit risky, but will further restrict access to our environment using SSH keys. So with this, we've come to the end of this lecture. Thank you for watching. I will see you in the next one. If you like this video, please subscribe to our YouTube channel. Hey guys, in this lecture, we'll create our virtual machines. So let's get started. Now open up another tab and type in console.cloud.google.com. I want to keep the first tab where we've created our firewall rules open so that we can reference the names of the target tags that we've selected. Now from this, make sure that the project is selected as Elasticsearch demo and then click on navigation menu. Then I need you to go to compute engine and then from compute engine type in instance or select instance templates. Now instance templates allow you to create reusable templates that can be used to create virtual machines. Now since this is a demo lab, we'll break our virtual machines and we might have to delete them and recreate them. It is easier if we create an instance template, then we can just reference that template and quickly create our virtual machines. So from here, click on create instance template. Now you'll see all the settings on the left, and on the right you'll see the total amount of free trial credits that you've got, and then also the monthly estimate of running this instance throughout the month. So now let's configure our template. First, the name will be ELK. Then under machine configuration, we'll keep the machine series as N1 and choose the machine type as N1 standard 4. It gives us 4 vCPUs and 15 gigabytes of memory. Then we'll change the boot disk to 100 GB. So let's click on select. Now once I make changes to these configuration settings, what you'll notice is that the monthly estimate changes. So this way you can fairly estimate how much it will cost you to run the machine for the whole month. Now at the bottom, I'll click on Management, Security, Disks, Networking and Sole Tenancy. Here I'll click on the Networking tab. I'll make sure the network is selected as Elasticsearch VPC and the subnet is selected as monitoring, because ELK servers need to go into the monitoring subnet. For network tag, I'll reference the firewall rule for kibana, and here I'll type in kibana and then click on create. Next, I'll create the instance template for web servers. So I'll name it web server. I'll keep default for every setting and then straight go to firewall. Here I'll select allow HTTP traffic. Then click on networking. Here I'll change the subnet from monitoring to web servers. Make sure the network is selected as Elasticsearch VPC. For network tag, I'll again cross-reference my firewall rule, and the target tag here is web servers, so this is what I'll put in. Then I'll click on create. Now I've set up two instance templates. So now it's time to start creating the virtual machines. So click on VM instances, then click on create. Now from the left menu, choose new VM instance from template. Now we'll create the ELK servers first. So choose ELK and then click on continue. Here we'll leave the name as default. In the region tab, we'll choose US West 1. For zone, you can choose any zone from US West 1. Just make sure for all your instances, the zone is same. So think of a zone as a data center. You want all your instances to be in the same data center. Then we'll keep everything else as default. Click on Management, Security, Disk and Networking, and then click on Networking. Make sure that our instance is in monitoring subnet and then click on create. Next, we'll create the second instance for web servers. Now here I'll again choose new VM instance from template. This one would be a web server, so let's select that and click continue. Now we'll make sure that our instance is in US West 1. We leave all the settings as it is. Click on Management, Security, Disk and Networking. Double check that network tag is there. Now here the subnet says monitoring for some reason, so we need to change that. So what we need to do is we'll need to reassign the subnetwork from monitoring to web servers, just to make sure that the instance is in correct subnet, and then click on create. Now click on create instance again. Select new VM instance from template. Choose web server, click on continue. Now we'll need to make sure that it is in the correct region, US West 1. We'll leave everything else as default. Go to Management, Security, Disk and Networking. Click on Networking, and we'll have to correct the subnet here as well. So just choose web servers, click on done and click on create. So this way we have created 3 virtual machines, one for our ELK applications and 2 web servers. Now there's a couple of things to note here. On this On the left hand side, you'll get the names of all these virtual machines. You can also get the zones. You can see that they're all in the same zone, which means they're all theoretically probably in the same data center, or in the data center that are very close to each other. You have the internal IPs, so that are mapped to the particular subnet they're in. You have the external IPs, and you need to make note of these external IPs because this is how we'll connect from our machine into the public cloud. So with this, we've come to the end of this lecture. Thank you for watching. I will see you in the next. Hey guys, in the previous lectures, we have set up our account and created the underlying infrastructure for our lab. In this lecture, we'll validate connectivity to our environment from our local Linux machine. We'll first do it through SSH keys, and then we'll also validate that Ansible can access your GCP instances. So here I am in my Linux VM. I've opened up terminal, and in the terminal I'll first check if I've got a .ssh folder. So I'll try and cd into it. So it says no such file or directory, so that means my Linux machine does not have any SSH keys yet. So let me type in ssh-keygen to create my SSH keys. I'll just enter out of all the other prompts. Now if I try and cd into the .ssh directory, I'll be successful. And if I do an ls here, you'll see that I have a private key file id_rsa and a public key file id_rsa.pub. What I'll do now is I'll do a cat on the contents of the id_rsa.pub, my public key file. Then I'll open up my Chrome window, go to console.cloud.google.com. Here I'll first make sure that I'm in the correct project, Elasticsearch-demo. Then I'll go to the navigation menu, then go to Compute Engine, and then metadata inside Compute Engine. Here I will select SSH keys, then click on Add SSH keys. Then I'll go back to my terminal window and select the contents of my public key file. Now I'll right click, copy, and I'll go back to the Chrome window and paste the contents inside the text box. And then click on save. Now what this operation does is it saves the SSH key contents into the Compute Engine platform to allow access, and it also creates a new user called Labit onto all of the virtual machines inside this demo project. So I'll go to VM instances, and then I'll open up my terminal again, minimize it, put it on the side, maybe here. Okay, I'll clear everything and get out. And now I'll try accessing the virtual machines in GCP from my local Linux machine. So SSH labit at, and then I'll type in the public IP address 34.83.54.213. I'll type in yes, and as you can see I was able to access the GCP virtual machine. So I'll exit out of this and continue this for the other two web servers. So SSH labit at 35.197.4.60. Type in yes again. Successful. So I'll exit out of this as well. and then SSH labit at 34.83.49.10. Yes, and successful again. So as you can see, I'm able to SSH from my local virtual machine to my virtual machines inside GCP using SSH by adding my SSH public key into the metadata section of the compute engine. Next, we'll validate the connectivity from Ansible into the GCP environment. To do that, let's first clear this. Now, let's go to Documents. Here, I'll create a new directory called Elasticsearch, or rather, I'll create a new directory called Ansible. Go into Ansible, and then here create a new directory called Elasticsearch. Go into Elasticsearch, and then here create a new directory called Inventory, and then go into Inventory. Here I'll create a host file, nanohosts.yml, and here I'll create a new group called ELK, and then in that group I will assign the public IP address of the ELK server, so 34.83.54.213. Now I'll create another group called web servers. Here I'll type in the public IP address of the web servers, 35.197.4.60, 34.83.49.10. Then I'll create a group called all. Here I'll type in the three public IP addresses, so 34.83.54.213 and then 35.197.4.60 and 34.83.49.10, and then I'll save this file. Now what I can do is I can type in Ansible -i hosts.yaml -m ping all. Let me just maximize this. So I've typed in Ansible -i because I'm in the current directory. I can straight away give hosts.yaml -m ping all and then hit enter. So finger crossed, I should be able to access my public IP addresses. So as you can see, I'm getting success back. So which means from here onwards, we can run the Ansible playbooks directly from our local machines onto the GCP servers. With this, we've come to the end of this lecture. Thank you for watching. I will see you in the next one. If you like this video, please subscribe to our YouTube channel.
Hey guys, in this video, we will install and configure Elasticsearch, Logstash and Kibana onto a single node Debian based Linux system. The steps for this lecture are: first, we will install Elasticsearch public signing key. Then we will install apt transport HTTPS package. After that, we will save Elasticsearch repository definitions onto our Linux system. Then we will do a system update and then install Elasticsearch, Logstash and Kibana. Once the three applications have installed, we will configure Elasticsearch and Kibana. I will dedicate a separate lecture for Logstash. And finally, we will test connectivity to our services. So let's get started. Here on the screen, I'm inside my GCP account and on VM instances page. We will use this page to create our single node Linux system. So I will click on create instance, then I will click on new VM instance from template, and then I will choose the ELK template and hit continue. Now from this screen, I can keep the name as ELK1, but I will change the region to US West 1, and then I will leave everything else as default and go to networking, and under networking, I will make sure it has the correct tag kibana, and I will also make sure that it is under Elasticsearch VPC and monitoring subnet. Once I validated these things, I will click on create to create my Linux instance. Now once this machine is up, I'll go to my Visual Studio Code. Here on the left hand side, I've got the notes to install ELK stack on a Linux machine, and on the right hand side, I've got my terminal. So here I will first go to my VM instances page, and from here copy the external IP address for my Linux instance, and then inside the VS Code terminal I will type in SSH labit at, and I will paste the IP address of my Linux instance and hit enter. Here I will type in yes. As you can see, I was able to successfully connect to my Linux instance. Now I'll first type in clear, and now we can start installing our applications. First I will do a sudo apt-get update. So sudo apt-get update and hit enter. And now once the system is updated, I'll first clear out the screen. Then I need to install wget if it is not already installed on the system. So I will do that now. Now after these prerequisites have been done, I can install the public signing key for Elasticsearch. So I will copy all this and paste it on the terminal and hit enter. Once I've got the OK message, I can install apt transport HTTPS package. So I will copy this command sudo apt-get install apt transport HTTPS and the yes and hit enter. Once this is done, I will clear out my screen again, and now we have to save the directory definitions. So I'll copy all this from my notes and paste it on the terminal, and I will hit enter. Now once the directory definitions have been saved, we can now install Elasticsearch, logstash and kibana. So the command is sudo apt-get update to update the system first, then we will install Elasticsearch, logstash and kibana. So I'll copy all this and I will paste it here, and I will hit enter. Now once all three applications have installed, it is now time to configure our applications. So I'll first clear out of this, then I will do sudo su, and then I will cd into first etc Elasticsearch to configure my Elasticsearch service. Now inside Elasticsearch configuration directory, if I do an ls, there is a file called elasticsearch.yml, which is the main configuration file for Elasticsearch. So we will type in sudo vi elasticsearch.yml to configure this file. Now in this file, the first setting that we need to change is cluster.name. So I'll first go into insert, then uncomment cluster.name. This setting is used to set a descriptive name for your cluster. So I'm going to call my cluster demo-elk. Now next setting I want to change is node.name. This setting is to set up a descriptive name for this node on the cluster. So I'm going to call it node 1. Now once I've done that, I can leave the defaults for path.data and path.logs, and I will need to go into network. Under network, the setting I want to change is network.host. By default, Elasticsearch is only accessible on localhost. We need to change that, so we'll change this value to 0.0.0.0. So 0.0.0.0. Now next we'll uncomment http.port, but we will leave it as is. So in a production environment, if you want to change the default port on which Elasticsearch is accessible, you will come here and change this value. Now we'll leave discovery as is. Because this is a single node cluster, we'll go right down, and towards the bottom what we'll do is we'll put in a setting called discovery.type. So I'll type in discovery.type, and the value for this setting is single node because this is a single node server. Now I'll go double check this in my notes, discovery.type as single node. So now we can save this file. So I'll do wq and hit enter, and to start Elasticsearch service I will type in systemctl start Elasticsearch and hit enter. Now once the service has started, we can first check the status of this service by typing systemctl status Elasticsearch, and the status shows active running. So I'll control C. Then let's test connectivity to our ELK cluster. So I'll type in curl -x get http and then localhost and then the port that Elasticsearch runs on, 9200. And then to check the health of cluster, I'll need to type in underscore cluster then health, and I want the output to be in a human readable format, so I will type in pretty and hit enter. Now the status came back as green and there is a single node on this cluster, which is what we wanted. So our Elastic service is installed and configured. I'll clear out of everything, and next it's time to configure kibana. So I will go into cd etc and then kibana and hit enter. Now here if I do an ls, you will see that there is a similar kibana.yaml file that we need to configure. So I will type in sudo vi kibana.yml and hit enter. Now inside the kibana.yml file, we'll first go into insert, then go to server.port and then uncomment it, but leave the setting as is. This is the port that Kibana runs on. In a production setting, you might want to change it from 5601. Next, we'll go to server.host, uncomment that and change it from localhost to 0.0.0.0. This will allow Kibana to be accessible by the outside world. So I've changed that. Now next setting that we want to change is server.public base URL. So I will uncomment this, and then here what I need to do is I need to type in HTTP and then the private IP address of my Kibana instance. So let's go to our VM instances page, and from here I'll copy the internal IP address. Now here I'll type in HTTP, then I'll paste the internal IP address of my Kibana instance, and then I will specify the port 5601. Next, I need to specify a descriptive name for my Kibana instance. So I will uncomment server.name, and here I will type in demo-kibana. Next, I need to specify the URL where Elasticsearch host is accessible. So here under elasticsearch.hosts, I will leave the value as default because it is running on the same server where Elasticsearch is running. So we can leave it as is. Now we can save this file, and now it's time to start Kibana. So systemctl start Kibana, and I'll hit enter. Looks like I made a typo. So systemctl start Kibana, and I'll hit enter. Now once the service comes back, I will do a systemctl status Kibana, and the service is active running. So let's go back to our VM instances. From here, I will copy the external IP address of my instance. I will open up a new browser tab, paste it here, and then specify the port where Kibana is running. So 5601, and I will hit enter. Now if Kibana is installed and configured successfully, you'll start seeing loading Elastic first. Now once Kibana has loaded properly, you'll see welcome to Elastic, and if you click on explore on my own, you'll get to the UI of Kibana. Now there's one last thing that I want to show you before I let you go, which is if you want your Elasticsearch and Kibana application to start automatically when you restart your system, what you'll have to do is you'll have to type in systemctl enable Elasticsearch and systemctl enable Kibana, and I'll remove the dot. And with this, we've come to the end of this lecture. Thank you for watching. I will see you in the next one. Bye. Hey guys, in this lecture, we will configure expect security on our Elasticsearch cluster. First, we will stop Kibana and Elasticsearch service. Then we will enable expect security inside our Elasticsearch configuration file. Then we will start the Elasticsearch service. After that, we will set up default credentials for Elasticsearch built-in users. Then we will configure Kibana to use password authentication to connect to our Elasticsearch cluster. And finally, we will start our Kibana service and test connectivity. So let's get started. Here on the screen, I've got my notes to configure expect security on our Elasticsearch cluster, and on the right hand side, I've got my SSH connection inside my ELK1 machine. So this is the single node ELK cluster that we deployed on a Debian package. So here, first I have to stop Kibana and Elasticsearch. So I will type in systemctl stop Kibana and systemctl stop Elasticsearch. Once I've stopped both services, first I will have to enable expect inside elasticsearch.yaml. So we'll go to Elasticsearch, and then here we will type in vi elasticsearch.yml, and on this file we'll go right down to the bottom, and I'll go into insert mode, and towards the bottom I will add the setting expect security enabled as true. So I'll copy it and I'll paste it here, and now I can save this file. Now next, I will have to start my Elasticsearch cluster. So I'll type in systemctl start Elasticsearch. Now once the Elasticsearch service has started, let's have a look at the status by typing in systemctl status Elasticsearch. It is active and running. Now in our previous video, we used the curl command to test connectivity to this cluster. Now if I do a control R and type in curl, and if we run this command again, let's see what happens. We get a security exception that we are missing the authentication credentials. So what we'll have to do now is we will have to generate the authentication credentials for our built-in users. So I'll clear out of the screen, and to do that, we will have to go to USR, share, Elasticsearch, and then bin. And if I do an ls here, you'll see there's a lot of utilities inside this folder. The one we are after is the Elasticsearch setup passwords utility. So I'll type in /Elasticsearch setup passwords, and here I have two modes. I can either go into interactive mode and set every password myself. So let me show you that first. I'll type in interactive and I'll hit enter, and it says initiating the setup of password for reserved users, and it gives the name of users, and it says you will be prompted to enter passwords as the process progresses. Please confirm that you would like to continue. So I'll type in no here first. What I would like to is for Elasticsearch to automatically generate passwords for me. So to do that, I will type in auto and hit enter. And now it says again, but this time it says the passwords will be randomly generated and printed to the console. So using auto, the passwords are auto generated, whereas using interactive, they are manually entered by the user. So I will type in yes to automatically generate my passwords. I've got the passwords here. So I'll copy all this and I'll paste it inside my notes. Now once I've done that, let me clear out of this and let's do cd to get out of everything and clear. Now let's run our curl command again, but this time what I want to do is I want to use the -u option to specify the username and password. Right after curl, I will type in -u and I will type in elastic as the username. Elastic is a super user on the Elasticsearch cluster, and then I will specify the password for my Elastic super user. So I'll do Control C, I'll paste it here, and then I'll put a space. And now if I hit enter, you'll see that I'm able to get the cluster information again. So that means our cluster is correctly set up with expect security and password authentication. Now next, our Kibana instance, if we try and start it now, will give us an error because it cannot connect to Elasticsearch. So we have to supply the Elasticsearch credentials for my Kibana instance to connect to the Elasticsearch cluster. To do that, we'll do cd etc Kibana, and then under Kibana, we'll edit the kibana.yml file. And inside this file, I'll go into insert and I'll go into the section where it says elasticsearch.username, and the built-in username used for this integration is kibana_system. So this is this username. So all we need to do is uncomment the password and remove the default value and copy the password for Kibana system user and paste it here. And once we've done that, we can save this file and let's start Kibana service. So systemctl start Kibana. Now let's do a status and the service is active and running. So now when we load the Kibana web page, it should ask us to authenticate. So I'll close this tab. I'll copy the public IP address of my machine again and I'll paste it and I'll type in 5601 and let's see what happens. Now this time it is asking us for a username and password, and here under username I'll type in elastic and under password I'll paste in the password for elastic super user. I'll click login and now you can see that I'm inside Kibana using my built-in user elastic. To look at all the user profiles on this Kibana instance, you can go into management and then you can go into stack management, and under stack management you can go into users, and from here you'll be able to see all the built-in users that were created when we configured expect security on this system. With this, we've come to the end of this video. Thank you for watching. I will see you in the next one. Bye. Hey guys, in the last few lectures, we've installed our Elasticsearch cluster. So now it's time to get some data into our cluster. First, we will upload non-time series data, and then we will upload time series data, and then I will show you the difference between both. So let's get our hands dirty. Here on my screen, I've got my Elasticsearch instance. So I will copy its external IP address, open up another browser tab, paste it, and type in 5601 and connect to my Kibana instance. Now once I'm on the home page of my Kibana instance, there is a button called upload a file. So I'll click on it to upload some data. Now using this button, you can upload files up to 100 MB in size, and they can be in the following formats. It could be a delimited text file like CSV or TSV, a delimited JSON file, or a log file with a common format for timestamp. For this lecture, we will upload delimited text files, which could either be CSV or TSV. Now to get some data set for this tutorial, I'll open up another browser tab and I'll go to a website called kaggle.com, and on kaggle.com I will go to datasets. So I'll hit enter. Now under this website, you will have to register or sign up to this website to download the datasets, and once you do, from the left navigation menu, if you're on datasets, you can search for the datasets using this search datasets button. Now you can also filter for the datasets that you want. For example, because I can only upload up to 100 MB files, I'll type in 100 MB here and I'll type in file type CSV, and the initial file size could be from 0 MB, and I'll click on apply. Now from the results, I'll click on the dataset called Netflix shows, and here I can see the size of this dataset, which is around 90 KB. If I click on compact, I can see some sample data inside the dataset, and now I'll click on download to download this file. Now this file downloads as a zip file, so I'll show in Finder, and from a Finder window, it's in my downloads, so I'll double click on it to extract this file. And now you can see I've got the file netflix.csv on my machine. Now I'll go back to Kibana. I can either drag and drop this file or I can upload this file. So I'll go to my downloads. Here I'll search for this file. So netflix.csv, and I'll click open. Now what Kibana does is it analyzes the first 1,000 lines of this file and gathers some data about this file. For example, it has found out that it is a delimited file and the delimiter is comma, and it also has a header row. Now we can click on override setting to override some settings on this file, or I can look at analysis explanation to find out how Kibana came to this conclusion. So I'll click on that and you can see some explanation of this analysis. I'll close this now. You can also see some file stats. For example, there are 13 distinct rating values in 999 documents. Once I've gone through all this, I will click on import to import this data. On the next page, it asks me to create an index. I can either do it using simple method or advanced method. For this demo, we will just use the simple method. Under index name, I will have to specify the name of the new index that will be created. So I'll call it Netflix index. Now again, index is the way how you store data in Elasticsearch. The next option is to create an index pattern. Now compared to an index pattern is how you can search and analyze that data in Kibana. So index is for storing data in Elasticsearch and index pattern is to analyze that data in Kibana. I want an index pattern to be created because I do want to visualize this data in Kibana. So I will click on import, and then you can see it first processes the file, then creates the index, creates ingest pipeline, then uploads the data, and then creates an index pattern for this data. Once all this is done, you'll get an import complete message. You can either view this data in Discover, do some index management. For example, you can specify when this data can be deleted from the index, etc., etc. Manage your index pattern, and we will talk about Filebeat later on. But for now, we do want to discover this index in our Discover tab. Now to get to the Discover page, another way is by clicking on these three lines from top left and then under Analytics and then Discover. On the Discover page, on the left hand side, the first piece of information is the index you're in. So if you had multiple indexes, you can click on this drop down and select the index you want to be in. Then you have the available fields, and if you have more than a few fields, for example, some indexes might have 100 fields or more, you can also search for a field name. So on this box, if I want to, let's say, search for rating, and I'll get all the fields which have the word rating in it. Now I'll remove that. Now on the right hand side, the first piece of information is the number of hits or the number of documents in this index. So we have 1,000 documents, and then each individual document. So if I expand that, you can see all the fields and their values that are in this document. Now against each field, you'll see 4 buttons. The first button is filter for value. So if I want to, in my index, filter for all the documents that have a rating description of 80, I can click on this button and it'll show up my filter on the top left here, and it'll filter the results on my Discover tab, all the results that match my filter. So you can see out of 1,000, I've got 15 hits where the rating description was 80. Now to remove a filter, I'll just click on this X. Now that was when you want to filter for a particular value. You can also filter out a value. For example, in this, I want all the movies which were not released in 2004. So I'll filter out for the release year 2004. So I'll click on this minus, and this will give me all movies where the release year is not 2004. And again, I'll remove this and expand one of the documents. Now next is toggle columns in a table. So on this table, there are no columns as of now. Now if you want to introduce columns to make your table look neater for you to search on, for example, if I want the first column to be title, I'll go against title, I'll click on toggle column in table, and now you can see all my documents are sorted by title. Now next, I want my column to be release year, so I will click on toggle column in table next to release year, and next I want my next column to be user rating score, and I will click on toggle column in table to include user rating score as well. Now to remove any of the toggled columns, I'll simply go to that field and I'll remove that column. Now I can sort by this column as well. For example, if I click on this arrow, it says sort user rating score ascending. So let me minimize this, and if I click on that, it will sort the user rating score in an ascending manner. And if I want to move it to descending, I'll click on this again, and it'll now sort this by descending. Now next, you can use this search bar to search your data set using Kibana query language. So first, let's see all movies that were released in the year 2000. So from my fields, I will look at which field gives me release year. So the field is actually called release year. So I'll type that release year, and now I can apply some operators. For example, colon means this release year is equal to some value. Less than equal to is basically release year less than or equal to some value. Greater than or equal to is what it suggests. Less than, greater than, colon, then a star to specify if my dataset contains a release year in any form. So that will filter out all the documents which have null or empty values for this particular field. So let's say is equal to 2004, and now I'll click on update, and this will show me all the titles that were released in 2004. Now to double check that, I'll add a release year by clicking on this plus sign on my table as well. So plus, and now you can see release year. Now let's say I want to add one more criteria to my search. What I can do is I can put a space after my initial search, and I can either do an and or or. So and is basically both arguments have to be true. So I'll type in and in my result set, this time I only want those movies which have a user rating score of 80 and above. So I'll type in user and select the field user rating score, and I want the value to be 80 and above. So greater than and equal to sign, and this time I'll type in 80 and click on update. Now out of those initial 8 hits, we only have these 4 hits. So this is how you can use Kibana query language to search on your data set. Now if you want to save this query, for example, if this query is repeated multiple times, you can save this by clicking on this floppy disk icon. So I'll click on that, and I will click on save current query, and I will say my demo query as the name of this query. Now because our data set doesn't have a timestamp field, I'm not going to specify include time filter, but if there were any filters in my data set, if I want to include them, I can pick that as yes, but I didn't put in any filters, so I'll remove that, and I'll click on save, and my query was saved. Now next time if I want to reuse my saved query, so let's say if I remove all this, click on update to get to my original set, and click on this drop down next to the floppy icon and click on my query, you can see I can quickly rerun the same query against my data set. Now next, let's download some time series data. Going back to Kaggle, I'll go to datasets. Now under datasets, I'll click on filters again. File size would be 0 to 100 MB, and on tags, I'll type in time series, and then I'll click on apply. Now out of the results, I'll click on the first result, Omicron daily cases by country, and here if I go down, I can see this data set is roughly 4 MB, and there's a single file COVID variants.csv, and I can click on compact, look at some sample data. So let's download this data. Now once this data file is downloaded, I'll again open in Finder, extract this file. Now got the COVID variants file. So I'll go back to my discover page, go to home page of Kibana. I can click on upload a file here, or I'll show you another method to do the same thing. So I'll go here, and then under management, I'll go to integrations. Here I can see there are a lot of default integrations built into Kibana. So first I will type in an integration for CSV, and I'll click on upload a file to get to my upload a file integration. We'll talk about integrations in an upcoming lecture. Again, I'll select the file. So COVID variants, I'll click on open, and this will analyze my data. Now after analyzing the first 1000 lines, it's found out that the data is delimited by comma, it has a header row, and it also has a timestamp, and the format for that time field is ISO 8601. Now I'll click on import, and I'll use the simple method again to specify an index, and I will give a name to this index of COVID underscore index. Now I can click on import. Now once you've got the message saying import complete, let's view this index in Discover. Now here, if I click on this drop down, you can see that I can switch between indexes using my index drop down. So I'll go back to COVID index. I can see all the available fields on the left side, and what's new this time is this time filter. So basically my data contains time field values between May 11 2020 and Jan 5 2021. 2022. So I can use that to basically narrow down on a specific date. So let's say I want to only look for data between 1st of December 2020 and 1st of January 2021. So what I can do is I'll click on this button against start date, and here I have to specify a start date. So I'll click on absolute for now, and I'll click on December, and I want this to be 1st of December 2020, and it can start at 00. So I'll click on that. Next, I'll click on end date, and here I'll specify 2021. I can leave this as January, and I'll click on 1, which was a Friday. Now I can specify some other time. Now let's say I want the data only up to 23:30 or 11:30. I'll click on that, and I'll click on update. So it'll only show me the subset of data that matches this time filter. So this is the difference between time series data and non-time series data. If you look at your Netflix index again, there was no time filter for you to filter on that data because our data did not had a timestamp. Now going back to the COVID index, you can also specify relative time frames. For example, you can specify data from, let's say, a month ago. So you specify 1, and you can specify one of the relative fields, for example 1 second, 1 hour, 1 minute, etc, etc. So I'll click on that, and for end date I'll go relative again, and I'll say from a month ago to 10 days ago. So from a month ago to 10 days ago, and click on update, and this will give me all data from a month ago to 10 days ago. Now instead of 10 days ago, I can also specify now and set the end date and time to now, and it'll give me all data for last 1 month. So this is the difference between time series and non-time series data. You do not have a time filter value in non-time series data. With this, we have come to the end of this lecture. Thank you for watching. I will see you in the next one. Bye. Hey guys, in this video I will show you how to install Apache Web Server on GCP VM instance. First, we will install the software, then we will deploy the new index.html file. After that, we will start Apache Web Server, and finally we will test access to our sample website. So let's get started. Here on the screen, I've got the VM instances console up for my GCP platform. Then I will choose new VM instance from template, and after that I will choose the web server template that we created earlier. Next, I will click on continue. After that, I will change the region to US West 1. Next, we will go down and click on networking, and under networking, we will make sure the network tag is web servers, and then we will need to change the network interface to be in the web servers network. So I will change that from monitoring to web servers, and after that I will go down and click on create. This will create our VM instance which we will use for web server. Now once the VM is up and running, we can move to Visual Studio Code. Now here on the Visual Studio Code console, I've got the nodes to install a web server on the left hand side, and on the right hand side I've got my SSH connection into this web server. So first we will update our system, so sudo apt-get update -y. Now I'll clear out. Next I will type in sudo apt-get install Apache 2 -y and hit enter. Next I will clear out of this, and then I will copy this command to create a new index.html file and put some sample code inside it to create our website. So I will paste it here and hit enter. Now once this is done, I can start my Apache service. So sudo systemctl start Apache 2 and hit enter. Now let's check for status. So sudo systemctl status Apache 2. It's active and running. And now let's head back to our GCP console, and here I'll copy the external IP of this machine and I'll paste it here and I'll hit enter. Now as you can see, we've got our sample web page up. So this is how you can install a web server on a GCP VM instance. Thank you for watching. I will see you in the next one. Bye.
Hey guys, we have our Elasticsearch cluster up and ready to work. Now is the time to start using the cluster. In this demo, we'll collect system monitoring data such as CPU and memory utilization, log data such as system logs to create some cool dashboards like this one to gain insights into our IT systems. Now, Elasticsearch uses lightweight shippers called beats that are installed on the target machines and send operational data to Elasticsearch cluster, and we can use this operational data to create reports and dashboards. Now, one of the most common use cases is to feed system metric data into Elasticsearch and use it to monitor things such as CPU or memory utilization, disk, etc. Now, system metric data is fed to Elasticsearch using a beat called Metricbeat, which is a lightweight shipper that you can install on your server to periodically collect metrics from the operating system and from the services running on that server. It takes these metrics and statistics and ships them to the output of your choice. For example, it could be Logstash or Elasticsearch. So to give you an example, let's say you want to monitor one of your Linux machine for its system metrics data such as CPU and memory utilization, etc. What you'll need to do is you need to install Metricbeat on this server and enable a module called system which collects all this information and ships it to Elasticsearch. This module allows you to monitor a lot of things that are listed on the screen. Each of these items individually is called a metric set. You can either choose to enable all of these or only the ones that you're interested in. The ones that you're not interested in will need to be commented out from your configuration file. Therefore, in theory, a Metricbeat module defines the basic logic for collecting data from a specific service such as Apache HTTP web server. The module specifies details about the service, including how to connect to that service, how often to collect metrics, and which metrics to collect. Each module has one or more metric sets. A metric set is the part of the module that fetches and structures the data. There are a lot of modules that you can enable in Metricbeat. In the description of this video, I put in a URL from Elasticsearch documentation, and you can browse it to have a look at all the modules available, and you can pick and choose the ones that you need based on your system requirements. Next, let's look at how Metricbeat service works. Metricbeat works in 4 steps. First, the service is installed and configured on the target machine. Second, it collects monitoring information based on the modules that are enabled and metric sets that are configured. Third, this data is stored and indexed inside Elasticsearch. And finally, we can create cool reports and dashboards from this data using Kibana UI. Or you can also use the default dashboards provided by Elasticsearch. Here's how we'll configure Metricbeat for this demo. On Apache web server, we'll enable Apache module which provides the status for the Apache web server. We'll also enable system module which provides system metrics. Finally, we'll also enable Beats XPack module. This module will help us monitor the Apache service. On the ELK server, we'll enable Elasticsearch XPack module which will help us monitor Elasticsearch itself. We'll also enable Kibana XPack module which will help us monitor Kibana, and we'll enable Beats XPack module which will help us enable other beats that are installed on that service. Now, one thing to note is that we will use the same Metricbeat instance to monitor itself. This is not what you'll see in a production environment. Your production cluster might look more like this, where you have a separate production cluster and a separate monitoring cluster, because in case of an outage on monitoring cluster, you might still have the production services being monitored through the production cluster, and also in case the production cluster dies, you can troubleshoot why it failed using the monitoring cluster. Now let's move on to our lab system. Install Metricbeat. Now once Metricbeat is installed, the first thing we need to do is we need to enable monitoring on the Elasticsearch cluster. So what we'll do is we'll go to our elasticsearch.yaml file. So I'll type in sudo nano /etc /elasticsearch /elasticsearch.yaml, and here I'll go right down to the bottom of this file. Here I'll make a comment for a new section and I'll name it XPack monitoring, and under XPack monitoring I'll copy these two settings: XPack monitoring collection enabled as true and XPack monitoring Elasticsearch collection enabled as true. These two settings enable the monitoring of our cluster. So I'll copy this and paste it here, and I'll save my file. After that, I'll restart my Elasticsearch service. So sudo systemctl restart Elasticsearch. So once Elasticsearch is up, we can install and configure Metricbeat. I'll type in sudo nano /etc /metricbeat /metricbeat.yaml. Here, the first setting I'll configure is live reload. What this setting does is it looks for the module configuration file under this path, and if there are any changes to this configuration file, it will reload them automatically without the need of restarting Metricbeat service. So I'll change this to true, and I'll uncomment reload.period. Now under general and name, we can specify a custom name for this shipper. By default, Metricbeat takes the host name of the machine that this shipper is running on. I can type in elk-1. Under tags, I'll specify that this is the elk machine. So I'll get rid of all this and I'll specify a tag called elk. Now under dashboards, we can either set up default Kibana dashboards for Metricbeat for this shipper by uncommenting this and setting this to true, or we can use the dashboards command. What I'll do is I'll set this to true here, but when we do the web server, I'll show you how to do it through the command. Now under Kibana, we'll need to uncomment host, but we can leave it as localhost because this shipper is running on the same machine as Kibana. And same for Elasticsearch, so we can leave it as localhost. Under protocol, let's uncomment this and change it from HTTPS to HTTP. And under username, we need to specify Elastic user, and under password, we need to specify the password for Elastic user. Now next, we need to specify logging. So we'll go to the section that's called logging, and here we'll need to uncomment logging level, but we'll leave it as default, and uncomment logging selectors as well. So we'll leave it as default all selectors. And after that, we need to copy these settings. So the first setting configures the logging to go to file, and after that we specify a path for the logging file. Then we specify the name of the logging file. After that, we specify how many files do we need to keep, and following which we will need to specify the permissions for the logging file. So I'll just copy all this and paste here. Now finally, we need to set up monitoring for our Metricbeat instance. So I'll uncomment monitoring.enable and I'll set this to true. And I'll go to the bottom where it says monitoring.elasticsearch and uncomment this. Now what this setting does is it picks up whatever we've specified in outputs for Elasticsearch as the output. So it will pick up the output from here. Now we can save this file and start Metricbeat service. So sudo systemctl start Metricbeat, and we can type in sudo systemctl enable Metricbeat to enable Metricbeat as well. Now after this, we need to configure and enable some modules. So if I go to etc/Metricbeat, and here if I do an ls, you'll see that there's a directory called modules.d. I'll go into modules.d and do an ls. You'll see that all the modules are present in this directory, but all of them are disabled except system module. Now for ELK server, let me first clear out and do the ls again. Now for ELK server, what we'll need to do is we need to enable Elasticsearch expect module, Kibana expect module, and disable the system module. So let's do that first. So sudo Metricbeat modules enable Elasticsearch-expect, and after that we can enable Kibana expect. Now we need to enable beat expect as well. This module will be used to monitor other shippers that we install on this server. So beat expect. Now if we so choose, we can disable the system modules. What I'll do is I'll disable. Now let's configure Elasticsearch expect first. So sudo nano Elasticsearch-expect. Here we need to specify the username and password for our remote monitoring user for Elasticsearch. So I'll uncomment both of these. I'll go to my files, I'll go to Ansible, and under credentials.yaml I've got all the credentials. So I'll copy the username first and the password for remote monitoring user, and let's just save it. And now let's just modify Kibana expect and do the same. Now we can save this. Now I just noticed that I've disabled Beat XPack instead of disabling system. So what I'll do is I'll enable Beat XPack first and I'll disable the system module. Now let me configure Beat XPack. Now here we need to specify the Beat system username. So I'll copy the username for Beat system user. So beats underscore system, and I'll uncomment this and I'll paste this and I'll save this file. Now Metricbeat should be configured on my ELK server. So I can go to GCP console, copy the public IP address of my ELK server, paste it in the browser with port 5601. Now from the Kibana homepage, I can click on menu from the top left. Let me just lock my dock and I can go into stack monitoring. And if I've configured Metricbeat correctly, I should start seeing some monitoring stats on my stack. Here I need to click on demo ELK. And as you can see, I've got monitoring information for my Elasticsearch, Kibana, and Beats. So let's click on Beat and click on ELK1. And you can see I've got my event rates. Now I can go to demo ELK and click on overview under my Elasticsearch to look at the health of my Elasticsearch index. I can look at search rates, search latency, indexing latency and rates. I can click on nodes to look at my nodes. I've got one node which is in green status. I can look at the CPU load and disk free space for this node. I can also look at my indexes. So I've just got one index called Metricbeat. Now I can go to Kibana and click on overview to look at Kibana. So like here I can look at client requests and client response times, the memory, how many instances I've got, maximum response time. And if I click on instances, I can look at the instances of Kibana that I've got as well. Now this is the setup for our ELK server. Next we'll have to configure our web servers. So what I'll do is from GCP console, I'll copy the public IP address of my web server 1. I'll open up new terminal. I'll paste the public IP address. Now on the left hand side, I've got the installation and configuration instructions for web server. And on the right hand side, I've got my SSH connection into the web server. So the first step is to install the public signing key for Elasticsearch. So let's do that. After that, let's just install the transport HTTPS package. After that, we need to save the directory definitions. Now we can do an update and install Metricbeat. So sudo apt-get update and sudo apt-get install Metricbeat. Now Metricbeat is installed. So let's first clear the screen. And now we can start configuring Metricbeat. Now this configuration would be similar to what we did for ELK server. So let's configure library loading first. Name would be web server. I will not set up the default Kibana dashboards because I want to show you how to do this through the command line. Now under host for Kibana, I'll need to put in the internal IP address of the ELK instance. So I'll go to GCP console, copy this and paste it here. Same for Elasticsearch. Now we can enable logging. Now after this, let's enable monitoring. And finally, we can uncomment monitoring.elasticsearch and save our file. Now let's start Metricbeat service. So sudo systemctl Now let's enable this service. Now let's have a look at the status of this service. It's running. So next what we'll do is we'll start enabling modules. So the first module we'll enable on this is the Apache module. After that we'll enable the Beat Expect module. Now let's have a look at the list of enabled modules on this machine. You can do that by typing in sudo Metricbeat modules list. You'll see that we've got 3 modules enabled on this machine: Apache, Beat Expect that we've just enabled, and system module is enabled by default. Now let's have a look at the module configurations. So let me clear this first. So sudo nano /etc/ metricbeat /modules.d /apache. Now here we'll uncomment metric sets and status. We don't need to put in any username and password because our default web server does not have any authentications. What I would recommend is that we change the value under hosts from 127.0.0.1 to either the IP address or domain name of our web server. This would help us to identify this web server in our dashboards. So what I'll do is I'll remove all this and I'll copy the internal IP address of my web server, go back to the terminal, and I'll paste it here. And now I can save this file. Now let's have a look at Beat Expect configuration. Now here we need to provide the username and password so that we can authenticate against the beats. So this would be the Beat system user, and this would be the password for Beat system user. Now this beat is used to monitor other beats on the system, but since we do not have anything installed on the system yet, this will not do anything. So let's just get out of this file. As I have promised earlier, now I'll show you how to configure dashboards through command line. To do that, we need to type in sudo metricbeat setup --dashboards and enter. Now once the dashboards are loaded, you'll see a message that says loaded dashboards. Now let's head back to our kibana instance. Here, let's first go to clusters and demo elk under stack monitoring, and let's just go down to beats. Now you can see that we've got 2 beats, elk1, and the other one should be our web server. So this data is from the internal monitoring about the beat itself. Now to get the information about the server, we need to go to metrics. Here you'll see that we've started to get metrics details about our web server. So we'll click on it and click on host metrics. And you can see that we've started to gather all the details about our web server as well. After this, let's move on to dashboards under Kibana to look at a sample dashboard produced by Metricbeat for an Apache server. Here under dashboard search box, I will type in Apache, and then I'll open up the dashboard named Metricbeat Apache Overview ACS. Now this is a sample dashboard. We can get stuff like the host names in our environment, uptime of our servers, total access bytes, busy and idle workers, different type of connections, CPU load, network load, etc. Now I'll let you guys configure web server too. With this, we've come to the end of this video. Thank you for watching. I will see you in the next one. Hey guys, let's install and configure Filebeat in this lecture. Filebeat is a lightweight shipper for forwarding and centralizing log data. It is installed as an agent onto your servers, and it monitors log files or locations that you specify, collects log events from those files or locations, and forwards them to either Elasticsearch or logstash. It has 2 components. The first one is called a harvester and the second one is an input. A harvester is responsible for reading the contents of a single file line by line. An input is responsible for managing the harvesters and finding all sources to read log data from. Now let's have a look at how Filebeat works. Now once you start the Filebeat service, it starts one or more inputs that look into the location that you specify for log data. For example, input 1 will look at var log and any log file inside var log. Now for each log file that it discovers inside this location, it starts a new harvester. This harvester is responsible to read the log file line by line, and it sends the data to a libbeat. Now this libbeat aggregates the events and sends the aggregated data to the output that you specify. For example, it can send the data to logstash or Elasticsearch. In this demo, we'll first configure Filebeat on our ELK server. There are 6 steps. So first we'll validate that the logs are set up correctly on ELK server. After that, we'll install and configure the Filebeat service. After that, we'll configure Metricbeat to monitor our Filebeat service, so we have some sort of monitoring in place as well. Then we'll start and enable the Filebeat service, and finally we'll enable and configure the ELK modules on our cluster for Filebeat. So Elasticsearch, Kibana, and system module. Now secondly, we'll configure Filebeat for our web servers. The steps are similar. The only difference is that the modules we'll configure on the Filebeat service for web servers will be Apache and the system module. So let's get started. Now here on my lab instance, I've got the steps to install and configure Filebeat on ELK server on the left hand side and the SSH connection into my ELK server on the right hand side. What I'll do is I'll attach these steps to the description of this video so you guys can have access to this document as well. Now on the ELK server, the first step is to validate that logging is configured for our Elasticsearch instance. So I'll type in sudo nano /etc/elasticsearch/elasticsearch.yaml. Now in this document, what I'll do is I'll go to paths and verify that path.logs is set to var log Elasticsearch and it's not commented out. If this is commented out for you, you'll have to uncomment it and make sure that path.logs is set up. Now, after we've verified that, we can exit out of this. Next, let's go to our Kibana instance. So sudo nano /etc/kibana/kibana.yaml. Now here we'll have to go down to logging. Now by default, you'll see that Kibana logs to standard output. So what we'll have to do is we'll have to change this. So I'll make space here, copy all this, paste it on the right hand side. Now what these settings do is first they configure logging.destination to be under var log and then Kibana file. Then we enable log rotation and we tell the system that we want to keep 7 log files. After we've done that, we can save this file. So yes, and enter. Now a problem with Kibana's configuration is that it cannot create the file Kibana under var log. So what we'll have to do is we'll have to do touch/var/log/Kibana. So we are creating a new file called Kibana under var log. Let me just do this with a sudo. Now after that, we have to change ownership of this log file Kibana to be owned by the Kibana user and group. So sudo chown Kibana /var/log/Kibana. So now this file's ownership is to the user Kibana and group Kibana. Now after we've done that, we can restart Kibana service. So sudo systemctl restart Kibana. Now let's have a look at the status of Kibana. And now let's see if Kibana file that we've just created under var log has started getting log data from Kibana instance. So let's do a tail -f/var/log/Kibana. And as you can see that we've started getting log data into our log file for Kibana. So let's exit out of this. Let me clear from here. Now The next bit of ELK stack we've installed on this server is Metricbeat. So let's double check that Metricbeat is configured with logging. So sudo nano /etc /metricbeat /metricbeat.yaml. Now in this file, let's go to the logging section. Now let's configure logging in this file. So I'll copy all this and paste here. Now after this, let's save this file as well. And let's restart Metricbeat service. So sudo systemctl restart Metricbeat, and let's have a look at status of Metricbeat. It's running. Now we've got logging configured on our ELK cluster. After this, what we can do is we can now install Filebeat service. So sudo apt-get install Filebeat. Now once Filebeat is installed, we can go to filebeat.yaml file and configure Filebeat service. So to do that, let's type in sudo /etc/filebeat /filebeat.yaml. Now here in this file, what we'll do is we'll first go down and configure live reloading. So under Filebeat modules, we'll go to reload.enabled and change the value from false to true. We'll uncomment reload.period and leave it as default 10 seconds. Now we'll go down in general section and give it a tag. So since this is an ELK cluster, I'll just give it a tag ELK. Now let's go down to dashboards and enable Filebeat's dashboards. So I'll uncomment this setup.dashboards.enabled and change the value to true. After that, under kibana section, I'll uncomment kibana host URL and I'll leave it as localhost 5601 because this Filebeat instance is installed locally where kibana instance is also installed. After that, I'll leave output as Elasticsearch and I'll leave the host section as localhost 9200. I'll change the protocol to HTTP. And I'll change the password to Elastic user's password and I'll uncomment both username and password. Now after this, I'll go to the logging section and configure logging for Filebeat. So I'll uncomment logging.level and I'll leave it as default debug, and I'll uncomment logging.selectors and I'll leave it as default star. I'll copy all this and I'll paste it here. Now finally, I can set up monitoring through Metricbeat. So I'll go down on this file and I'll copy http.enabled and http.port. Now what this does is it enables Metricbeat to monitor Filebeat over HTTP. So I'll paste this here. Now I can save this file. Now since we've enabled Metricbeat monitoring over port 5067, let's first check if beatxpack module in Metricbeat is enabled or not. So to do that, let's first check sudo Metricbeat modules list to list all the modules and the ones that are enabled. Now if you can see that we don't have beatxpack module enabled, so let's first enable this module because this module is used to monitor for other beats installed on the server through Metricbeat. So sudo Metricbeat modules enable beatxpack. Now once this module is enabled, we'll have to configure this module to watch port 5067. To do that, let me first clear out of everything. And then I'll type in sudo nano /etc /metricbeat /modules.d /beatxpack.yaml. Now in this file, what we'll have to do is we'll have to first change the URL under hosts from localhost 5066 to 5067 because this is the port where Filebeat is exporting its data to. Now under username and password, we have to use the Beat system username and password. So I'll remove that. Change the username to beats underscore system. And change the password to beats underscore system user password. And let me save this file. Now finally, we'll verify that Metricbeat service is running. So sudo systemctl status Metricbeat. And now we can start the Filebeat service. So sudo systemctl start Filebeat. Now let's have a look at the status of Filebeat service. Now this service is running. Next, what we'll have to do is we'll have to enable the modules on this service. So let me first clear out of everything and let me type in sudo filebeat modules enable Elasticsearch to enable the Elasticsearch module. After that, let me type in sudo filebeat modules enable kibana to enable the kibana module. And last, we'll do sudo filebeat modules enable system to enable the system module. Now we'll have to configure all these three modules. So let's go to sudo nano /etc /filebeat /modules.d /elasticsearch.yaml. Now in this module, you can see that it's got some paths. By default, it takes the paths based on your distribution. So because we haven't changed these paths to custom paths, we do not need to edit anything here. But if you have changed the paths to be custom paths in your installation, you'll have to come in here and do those configuration changes. So I'll get out of this file. Similarly, for kibana.yaml, the system based on the distribution takes all the default paths. If you've changed the paths, you'll have to come in here and do the changes. Now let's go to our kibana instance. So I'll copy the public IP address and 5601. I'll type in the name of Elastic user and password. Now first, if the beat is being monitored correctly, we should be able to see this file beat come up under stack monitoring. So let's go to menu and go to stack monitoring. Here let's click on demo elk and let's go down, and you can see that we've got two beats. We've got a file beat under the name of elk1. So let's click on this. So this is our file beat being monitored correctly, and we can see that we've got some event rates and throughput, etc. Now after this, if we go to clusters demo elk and have a look at the section under logs, you can see that we've started gathering logs. So we've got 22 informational logs and 2 deprecation or warning logs on our Elasticsearch. So this means that our Filebeat service is able to capture logs from our ELK cluster. Now let's move on to our terminal and exit out of our ELK server and move on to the web server. I'll copy the IP address of web server 1, go here, SSH, and I'll paste the IP address. Next, I'll close the instructions for ELK server Filebeat installation, and I'll open the ones for web server, and I'll open them in preview mode. Now, on our web server, first we'll have to validate that logging is configured for Metricbeat. So let's do sudo nano /etc /metricbeat.yaml. Now here we have to go down to the logging section. Here we'll uncomment logging.level as debug and selectors as star. We'll leave them both as default. We'll copy this section. So Control C, Control V. Now after this, let's save this file and let's restart Metricbeat. Now once the Metricbeat service comes up, we can install Filebeat. So let's check for status on the Metricbeat service first. Now let's do a clear. So we've got a clear screen, and here I can type in sudo apt-get install Filebeat. Now after this, we can configure our Filebeat service. So let me first clear and type in sudo nano /etc/filebeat/filebeat.yaml. Now the steps are same, so we'll go right down and configure library load first. Next, let's just add a tag and keep the tag as web tier because this is a web server. Let's set up dashboards. So setup.dashboards.enabled as true. Now after this, let's uncomment the kibana host. Now for the URL, what we'll do is we'll use the internal IP address of our kibana server. So I'll copy this and change localhost to the internal IP address of our kibana server. Then I'll go down to the Elasticsearch output section. Do the same thing for host URL here as well. Change protocol from HTTPS to HTTP. And enter the password for Elastic Superuser. Now I'll go down to logging section. Make sure logging is configured. Now finally I'll go right down and enable Metricbeat to monitor this service. So save this file and I'll check if beatxpack module is enabled for Metricbeat or not. So sudo Metricbeat modules enable beatxpack. Now I can configure this module. So sudo nano /etc/metricbeat/modules.d/beatxpack.yaml, and in this file I'll change the host port to 5067 because this is where Filebeat is configured. I'll use the beat system username and password. Now I can save this file. Now let's just do a status on Metricbeat. Make sure Metricbeat service is working. It is. Now let's start Filebeat. So sudo systemctl start Filebeat. Now after that, we can first status the Filebeat service to verify that it is actually started now. Now once we verified that the service has started, we can clear everything and enable the modules. So sudo Filebeat modules enable. First we'll enable the Apache module and then we'll enable the system module. Now once this is done, we can go back to our kibana instance And here, let's just refresh stack monitoring. Now on our Kibana instance, if we go down, we'll see that we've got 4 beats now. So we'll click on beats. And as you can see, we've got the file beat come up for our web server as well. We can check for the status of this beat by clicking on web server, and it should give us event rate, throughput, fail rates, etc. Now what we can do is we can have a look at one of the sample dashboards that Filebeat creates for an Apache web server. To do that, let's go to menu and then dashboard. And here under dashboards, let's search for Apache and let's click on Filebeat Apache Access and Error Logs ECS. Now this is a sample dashboard that Filebeat creates using the access and error logs from an Apache service. So you can use this to look at unique IP addresses that access to your server, the response codes over time, the browser breakdown, etc. So this is how you can install and configure Filebeat on an ELK server and a web server. What I want you to do is I want you to go in and install and configure Filebeat on your web server too. What you should expect is that once you do that, you should be able to get information like this for web server 2. And also, if you go to stack monitoring, under beats, you'll have 6 beats. So one metric beat and one file beat for your second web server. With this, we've come to the end of this video. Thank you for watching. I will see you in the next one. Bye. Hey guys, in this video, let's install and configure Auditbeat. Auditbeat allows you to monitor user activity and processes in your Linux system. It communicates directly with the Linux Auditd framework and sends the data it has collected to Elasticsearch in real time. There are 4 steps to install and configure Auditbeat service. First, we'll install Auditbeat. Second, we'll configure Auditbeat and configure the 3 modules available inside Auditbeat service. Currently, these modules are Auditd, File Integrity, and System module. After that, we'll configure Metricbeat to monitor the Auditbeat service. And finally, we'll start and enable Auditbeat service. Now, one thing to note is that there is no live reload option in Auditbeat. Before we move to the lab system, let's have a look at each of these modules individually. And first, let's look at Auditd module. Auditd module receives audit events from the Linux audit framework, which is part of the Linux kernel. What it does is it establishes a subscription to the kernel to receive audit events as they occur. Now, one thing to note is that you might need to stop other services that are running on your system such as Auditd and GeneralD for this module to work. There are 2 different types of rules that you can configure inside Auditd module. The first rule is a file system rule. What this rule does is it allows the auditing of access to a particular file or a directory. Think of it as putting a watch on that particular file so you are notified when the file is being accessed or modified. The syntax of this rule is -w, pass to the file that you need to put the watch on, -p, permissions such as read, write, execute, -k, key name. The next type of rule you can configure is a system call rule. What this rule does, it allows the logging of system calls that any specified program makes. The syntax of this rule is -a, action, which could be always or never, filter, which could be task, exit, user, or exclude, followed by system call, which is specified by its name, and finally you can use field and value to further modify the rule to match events based on a specific thing such as architecture, group ID, process ID, etc. Now next, let's have a look at file integrity module. File integrity module sends events when a file is changed, which means when a file is created, updated, or deleted on disk. It does that by creating a subscription with the OS to receive notification of changes to specific files or directories. Now, what it does is when you first start up this module, it performs an initial scan of all the paths that you've configured, and then it monitors those paths to detect any changes from since you've last run this module. It uses locally persisted data in order to send only events for new or modified files. Now, after this, let's have a look at the system module. System module collects various security related information about a system. All datasets send both periodic information, for example, a state of current running processes, and real-time changes, for example, when a process starts or stops. Each dataset sends 2 different types of information, state and events. State information is sent periodically and on system startup and can be controlled by using a configuration called state.period. Event information is sent as the event occurs, for example, when you start or stop a process. For event information, all datasets use poll model to retrieve that data. Frequency of polls can be controlled by the period configuration parameter. Now let's move on to the lab system. Here on my lab system, I've got the instructions to install and configure Auditbeat on ELK server on the left hand side, and on the right hand side, I've got my SSH connection into the ELK server. So first, we'll have to install Auditbeat. To do that, let's type in sudo apt-get install Auditbeat. Now one thing to remember is that we are able to do this because we've done all the prerequisites to add Elasticsearch repository, the signing key and apt transport HTTPS package on this system already when we did the installation of Elasticsearch. If you haven't done that, you will not be able to do this step. So you'll have to go back to the step where we've installed Elasticsearch and do all those prerequisites on this machine. Now after Auditbeat is installed, we can type in sudo nano /etc /auditbeat /auditbeat.yaml to open up the Auditbeat configuration file. Now in this file, the first thing we'll do is we'll configure the modules. So first we'll configure auditd module. To do that, let's go down and you'll see there's a section called identity changes, and this section allows you to put in file watch rules that watch files such as group, passwd and gshadow file. You can either uncomment these to enable these rules, or let's add a custom rule to put a watch on our Elasticsearch and Kibana configuration files. So I've got the rule here, -w, path to file is path to the elasticsearch.yaml file, -p for permissions, and then permissions are wa, and then the key is elk changes. So let's just copy these two and paste it here, k for key, and let's just also enable these rules. Now we can also watch for unauthorized access attempts to our system, so let's use the default rules to do that. Now next, let's configure the file integrity module. Now under file integrity, you will see that there are some paths that are already configured, such as bin, user bin, sbin, etc. Now let's add our custom paths for Elasticsearch and Kibana. So copy, paste. Now after this, what I want to show you next is that there might be files that you do not want to monitor in the path that you specify under file integrity module. You can exclude those files by using the exclude_files setting. So I'll just copy this setting and paste it inside this file. Now what this setting does is it looks for a file name or a pattern for that file name and excludes those files from being watched. Now I've used a regex pattern that excludes the reference files, so elasticsearch.reference or metricbeat.reference file, from being monitored. Next, let's have a look at the system module. There are two types of information that you can capture from system module. First is the event information. So this could be something like which packages were installed on your system or removed or updated. The frequency to monitor this information can be modified using the period setting. Currently the default is set to be 2 minutes, so let's leave it at that. Second is the state information. State information can be monitored for things such as host, login, process, socket and user by default, and this information can be collected for a frequency of 12 hours by default, but this can be modified by modifying the value of state.period variable, but we'll leave it as default at 12 hours. Now we'll leave the rest of the settings as default and we'll move on to the general settings. First, we'll configure a tag. So under tags, I'll uncomment it and add a tag called ELK. Next, under dashboards, I'll enable the default dashboards. After this, let's move on to the section Kibana. Here, let's uncomment the host URL. Now, after this, let's move on to the Elasticsearch output and uncomment protocol and change the protocol value to be HTTP. Next, let's add in the Elastic users authentication details. Now after this, let's configure logging. So I'll uncomment logging.level but leave it as default debug. I'll also uncomment logging.selectors and again leave it as default as all selectors. Now let's configure the logging to be to a file. So let's copy this section, paste it here. Now after this, let's go down and configure the HTTP monitoring. So let's copy these settings, http.enabled and http.port. Now for Auditbeat, we'll configure the monitoring port to be 5068 because if you remember 5067 is being used by Filebeat in this demo. Now we can save this file. Now after this, let's first check that beatxpack module is enabled in Metricbeat. So sudo Metricbeat modules list. Now you can see that beatxpack is enabled. Now after this, let me just clear everything. And now let's edit the beatxpack module configuration file. So sudo nano /etc/ metricbeat /beat /modules.d /beatxpack.yaml. Now in this file, let's add the monitoring for Auditbeat. So under hosts, after the monitoring information for Filebeat, I'll type in http localhost 5068, and now let's just save this. Now after this, we can start Auditbeat. So sudo systemctl start Auditbeat. Now let's check for the status of Auditbeat service. Status Auditbeat. Now this has failed for some reason, so let's investigate. First, a good idea would be to look at the information that we've entered and make sure the syntax is correct. So sudo nano etc/auditbeat /auditbeat.yaml. Now it looks like that exclude files is configured incorrectly, so let's just put some spaces here so that it follows the YAML syntax. Now let's just save this file and let's just try and restart our Auditbeat service. So sudo systemctl start Auditbeat. Now let's just do a status again to see if it has come up. Now it looks like that was the issue and our Auditbeat service is now running. Now let's move on to our Kibana instance to see some dashboards that it has created by default for us. Now here, let's just first move to stack monitoring and demo ELK, and let's go down to beats, and you can see that we've got Auditbeat service here. Now we can click on beats and then click on the Auditbeat service, look for some information about Auditbeat, or we can go to home and then dashboard. Now here we can open one of these Auditbeat dashboards. So let's just open up the file integrity dashboard. Now this is a sample dashboard that we can get out of Auditbeat. You can see that the initial scan count was 1043. You can see the time the initial scan was done, top owners and groups for our files, the file that was most changed by file count, and some file event summaries. Now after this, let's move on and quickly configure Auditbeat for our web server. Now here on the lab system, I've got the SSH connection into my web server. So I'll type in sudo apt-get install Auditbeat. Now after this, let's configure Auditbeat quickly. So sudo nano /etc/auditbeat /auditbeat.yaml. Now let's add the file watches. Now on the web server, what we'll do is we don't have Elasticsearch and kibana.yaml files. So I'll just copy this rule, but then I'll modify it for my Metricbeat and Filebeat.yaml files. So I'll save it here and I'll change the path to file from Elasticsearch to etc Metricbeat /metricbeat.yaml, and we'll change the key to beat changes. Now I can copy this and paste here and change it to Filebeat and filebeat.yaml. So /etc/filebeat/filebeat.yaml. Now, since it's a web server, one important file that you might want to watch on this server would be your Apache web server files. We can copy the same rule and change the path to point to the web server path. So /var/www/html/index.html, and we'll change the key to web server. Now after this, let's move on to the file integrity module, and here let's monitor var www/html. Now we don't need to make any changes to the system module. Now let's move on to tags under general, and here let's uncomment the tags setting and let's add the tag for web tier. Now let's enable the default dashboards. Now let's go down under hosts and add in the internal IP address of my ELK server. So 192.168.1.34, and let's just do the same for Elasticsearch output. Let's change the protocol to HTTP and let's add in the password. Now let's go further down and add logging, and finally let's configure XPack monitoring. Now let's just save this file, and now let's add the monitoring information inside Beat XPack. So sudo nano /etc/metricbeat/modules.d/beat XPack. Now in this file again, comma space http localhost 5068. Now we can save this file as well. And now let's start Auditbeat. So sudo systemctl start Auditbeat. Now let's look for the status of Auditbeat service. So sudo systemctl status Auditbeat. It's running. So let's move back to our kibana instance. Now here let's go to stack monitoring first and let's click on demo ALK, and here you can see that we've got two Auditbeats. Now you can also now go to dashboards and let's choose a different dashboard this time. So let's just choose the system overview dashboard. Now this dashboard gives you an overview of your environment, such as number of hosts in your environment, login count, login actions, user changes, OS distribution, process starts and stops, sockets opened and closed, package changes, etc. You can also get a list of your system events on the bottom right. Now what I want you to do after this is to go and install Auditbeat yourself on web server 2, and also try and explore other dashboards available under dashboards for Auditbeat to look at what sort of information you can get out of this service. With this, we've come to the end of this video. Thank you for watching. I will see you in the next one. Hey guys, let's install and configure Heartbeat in this video. Heartbeat allows you to periodically check the status of your services and determine whether they are available or not. Now, for an example, think that you have a web server, and if you log into the console of that web server and do a service check on the HTTP service, the service comes back as running. But when you try to load the web page doesn't load. You get an error on the web page, which means your users are not able to use your website for whatever they were trying to use it for. Now, you can use Heartbeat to monitor for those sort of scenarios. So what Heartbeat will do is it will check for a status code back from that web server, and if it's not getting that status code back, it will show that web service as unresponsive or down. Now there are three different type of monitors that you can configure inside Heartbeat. First, you can configure an ICMP or a ping monitor. So it basically pings that particular IP address or hostname, and if it gets a successful ping, it shows it as up, and if it's unsuccessful, it shows that monitor as down. Next, you can configure TCP. This monitor allows you to connect to a particular endpoint through TCP, and you can also modify this monitor to check that the endpoint is up by receiving a custom payload from that endpoint. Now, third, you can also configure an HTTP monitor to connect via HTTP to your endpoints. This monitor can also be optionally configured to check for specific responses or status codes from your endpoints. Next, there are 5 steps to install Heartbeat. First, we'll have to install Heartbeat-Elastic package. After that, we'll configure the Heartbeat service. Third, we'll configure Metricbeat to monitor our Heartbeat instance. Fourth, we'll configure our monitors, which is HTTP, ICMP, and TCP monitor. And finally, we'll start and enable the Heartbeat service. So let's move on to the lab. Now here on the lab system, I've got the instructions to install and configure Heartbeat on ELK server on the left hand side, and I've got my SSH connection into my ELK server on the right hand side. Now one thing to note is that we'll be installing Heartbeat only on ELK server in this demo. So to install Heartbeat, let's type in sudo apt-get update and sudo apt-get install Heartbeat-elastic and hit enter. Now once Heartbeat is installed, let's start configuring the Heartbeat service. So we need to type in sudo nano /etc/heartbeat/heartbeat.yaml. Now in this YAML file, let's first configure live reload. So change reload.enable to true, and we'll leave the default reload period as 5 seconds. After this, let's first comment out all the inline monitors, because we'll be using the monitors path to configure these monitors. Now the path is /etc/heartbeat/monitors.d and any YAML file inside this path. So once you've commented out all the inline monitors from this heartbeat.yaml file, let's go to tags and create a tag. Here we'll specify the tag as ELK. Now after that, let's move on to kibana, and under kibana section we'll uncomment the host portion, but we'll leave the URL as default localhost 5601. Now let's move on to the Elasticsearch output, and we'll leave the URL as default localhost 9200, change the protocol to HTTP, and we'll provide the authentication details. Now after that, let's move on to logging section. We'll uncomment logging level. We'll also uncomment logging selectors, but keep the default values for both. Now I'll copy this configuration from my instructions to specify logging to go to a file. Now once this is configured, we can now configure HTTP monitoring for our Heartbeat instance. So I'll copy these two values. Now if you'll notice, we're using port 5069 for monitoring for our Heartbeat instance. We'll add this port into our beatexpac configuration file after this. So let's save this file for now. Now let's first go to our Metricbeat. So etc Metricbeat modules.d and beatexpac.yaml file to configure monitoring on port 5069. Here I'll add a comma, and now I'll add the URL. So http localhost 5069. Now I can save this file. Let's now first check Metricbeat is running. So sudo systemctl status Metricbeat, it's running. Now let's also double check that beatexpac is enabled. So sudo Metricbeat modules list, and you can see beatexpac is under enabled, so that's all good. Now let's clear out of everything and we can start our Heartbeat instance. So sudo systemctl start heartbeat-elastic. Now let's first check for the status of this service, make sure it's running. It is. And now it's time to configure our monitors. So to do that, let's first go to etc heartbeat and monitors.d. Here you'll see that there are some sample monitor files available. We'll use these and customize them to create our own monitor files. So first I'll type in sudo copy sample icmp.yaml.disable and I'll copy it to icmp.yaml. Now I'll do a nano on icmp.yaml to configure our ICMP monitor. Now for our ICMP monitor, we'll first have to change the ID and name. For ID, I'll use ICMP-status. For name, I'll use ICMP status check. Now let's uncomment this to enable the monitor. Now we'll leave the schedule as default every 5 seconds so that our hosts that we specify under the hosts array are pinged every 5 seconds, and we'll have to specify a list of hosts here. Now what I'll do is I'll first specify the internal IP address of our web server 1, and then just to demonstrate I'll add the external IP address of our web server 2. So 192.168.2.19, which is the internal IP address of my web server 1. I'll do a comma space and I'll copy the IP address of my web server 2 here. Now what I'll also do is I'll just add a publicly accessible external IP address here as well, and this IP address 8.8.8 is always up. Now next we'll leave the mode as default. You can disable by IPv6 right now, but let's leave it as default. You can also specify a timeout or a wait. We'll go to tags section next and add a tag called web tier, and now we can save this file. Once this is done, let's move on and configure our TCP monitor. To do that, let's just copy the sample TCP monitor file. So sudo copy sample tcp.yaml.disable to tcp.yaml, and now let's modify this tcp.yaml. Now here, first we'll have to specify the ID again. So let's type in SSH status because we'll use this monitor to check the status of SSH connection, and under name I'll type in SSH status check. Now after this, let's enable the monitor. We'll leave the schedule as default 5 seconds, and under hosts I'll specify the internal IP address of my web server 1, and I'll specify the port. So the SSH port is 22. Now I can either specify the port here or specify a list of ports to ping if the host does not contain a port number under the ports option. So these are the two places you can specify ports. We'll leave all the other values as default. One thing to note is you can use check, send and receive to add custom payloads, but we'll move on to the tags section and add the tag for web tier, and I'll save this file now. Next, let's move on and copy the HTTP monitor. So sudo copy sample.http.yaml.disable to http.yaml. Now let's modify http.yaml. So sudo nano http.yaml file. Here under ID I'll specify web status, and name could be web status check. Let's enable the monitor, and under hosts I'll add my Elastic and my Kibana URL. Now after that I'll have to specify authentication because we've configured XPack on our system. So I'll type in the username and password. So Elastic and the password for Elastic user. Now we can use the other settings to specify a custom status check or a custom payload on this request as well, but we'll leave these as default and move on to the tags portion. Specify the tag as web tier. Let me uncomment this, and now we can save this file as well. Now before we move on, let's check for the status of our Heartbeat service once again. It's running, so now let's move on to our Kibana web page. Now the first thing to check would be that Heartbeat appears under stack monitoring. So let's go to home and then stack monitoring. Here let's click on demo ELK and let's go down to beats, and as you can see we've got Heartbeat under beats. Now we can click on beats and then Heartbeat to check for the status of our Heartbeat instance. Now for the actual monitors we need to go to our home page and then uptime under observability. Here you can look for all the monitors that were up or down. Now by the looks of it, all our monitors are up right now. You can use the filter up and down to filter against a specific status that you want. Now on top right you can specify the time. So for example, you can specify if you want the data from 15 minutes ago or 15 days or hours ago. You can also specify the amount of time, or you can specify an absolute time. Now you can also check for ports. Now we've got 3 ports configured, 9200, 22 and 5601 for our checks. You can specify the scheme ICMP, HTTP or TCP to filter out the endpoints, or you can look for tags. So we've got ELK and WebTier tags. So let's click on WebTier. So if you do that, you'll only see the monitors that are specific to that particular tag. So with this, we've come to the end of this video. Thank you for watching. I will see you in the next one. In this video, let's discuss how you can install and configure Packetbeat to monitor network traffic between your applications. Packetbeat is a real-time network packet analyzer that you can use with Elasticsearch to provide an application monitoring and performance analytics system. It works by capturing the network traffic between application servers, and it decodes the application layer protocols such as HTTP, MySQL, etc. You can deploy Packetbeat on the same server as your applications reside on, or on its own server. In a cloud environment, because the underlying network devices are not exposed to you, it's hard to deploy Packetbeat on its own server. So in this demo, we will deploy Packetbeat on our web server and monitor our HTTP traffic using Packetbeat. There are 4 steps to deploy Packetbeat. First, we'll install Packetbeat. Second, we'll configure Packetbeat and configure traffic sniffer and network flows for our Packetbeat monitoring. Third, we'll configure Metricbeat to monitor Packetbeat. And finally, we'll start and enable Packetbeat. So let's move on to our lab system. Now here on the left hand side, I've got the instructions to install and configure Packetbeat on web server. On the right hand side, I've got my SSH connection into my web server 1. Now first, let's install Packetbeat. So we can type in sudo apt-get install Packetbeat and hit enter. Now once Packetbeat is installed, we can start configuring it. To do that, let's first cd into /etc/packetbeat. And here, if I do an ls, you'll see that I've got my packetbeat.reference file, which I can reference when I'm configuring my Packetbeat installation. I've got the configuration file, which is packetbeat.yaml. So let's do sudo nano packetbeat.yaml. Now in this file, the first thing I have to configure is the network interface from which I want to sniff the network data from. On Linux machines, this can have a value of any, which means it will sniff network traffic from all connected interfaces, or you can specify a particular network interface to only target network traffic on that interface. Now we'll leave it as default any. Next, on Packetbeat, flows are enabled by default. To disable flows, you can set enabled as false in flow configuration to disable it, but we'll leave it as enabled. And now it's time to configure the protocols for which we want to monitor network flows. Now this is under packetbeat.protocols. Now here we will monitor network flows for ICMP, DHCP-v4, DNS and HTTP. So to disable the rest of the flows, we'll have to comment them out. I'll do that now. Now one thing to note is that this ports field is used to configure the ports for which you want to monitor the flow information for. Now your web server might be running on a port that's different from one of these default ports. For example, your web server might be running on, let's say, port 8001. Now to monitor flow for your web server in that scenario, what you'll have to do is either come in here and add your specific port like this, and also delete the rest of them. Now since we are running on port 80, what I'll do is I'll remove all the other ports and I'll now move on to the next section, which is general. Here I'll uncomment tags and I'll keep the tag WebTier. Now after this, let's set up some dashboards. So we'll configure setup.dashboards.enabled as true. So let me just first uncomment this and set this to true. This will enable default dashboards for Packetbeat on our Kibana instance. Now after that, we'll have to uncomment the host section for Kibana and correct the URL. This will be the internal IP address of our Kibana instance. So 192.168.1.34. Now after that, let's move on to output. Under output, the first thing we have to do is correct the URL for my Elastic output section. So 192.168.1.34, which is internal IP of my ELK instance. Next, under protocol, let's configure the protocol to be HTTP. Now after this we have to set up authentication, so I'll enter Elastic user and its password. Now next let's set up logging. I'll uncomment logging level but leave it as default debug. I'll also uncomment logging selectors but leave it as default star, which means all selectors. Now to set logging to a file, I'll need to copy this configuration and paste it here. Now what this configuration does is it first enables logging to be sent to a file. Then we specify the parameters for the file that logging needs to go to. For example, the path, name of the file, number of files to keep, and the permissions on that file. Now after this, let's set up HTTP monitoring through Metricbeat. So I'll copy these two settings and paste it here. Now the first setting enables HTTP monitoring, and the second setting tells Packetbeat which port it needs to send its monitoring data to. Now what we'll do is we'll configure this port in our beat expec file under Metricbeat. So let's first save this file. Now after this, let's edit our beat expec file. So sudo nano /etc/metricbeat/modules.d and beat expec. Now in this file under host section we have to add the URL for our Packetbeat monitoring. So I'll add comma space double quotes and HTTP localhost, and the port is 5070. Now I can save this. Now after this, let's first check that Metricbeat is running. So sudo systemctl status Metricbeat. Now this is running. Now let's start our Packetbeat instance. So sudo systemctl start Packetbeat and hit enter. Now let's do a status on Packetbeat. So sudo systemctl status Packetbeat. It's running. Now let's move on to Kibana UI to look at some of the default dashboards that are created by Packetbeat. Now from homepage of my Kibana UI, I'll first go to the menu and I'll go to stack monitoring. Now here I'll click on demo ELK and I'll go to the section for beats, and I can see that there's a beat called Packetbeat. So I can click on beats and let's click on web server 1, which has type Packetbeat, and you can see that we've started receiving some data through our Packetbeat instance. Now to actually look at some dashboards that have been created by Packetbeat for us in our Kibana UI, let's go to menu and dashboards, and here let's type in Packetbeat and then let's click on the dashboard that says Packetbeat HTTP ECS. Now here this dashboard gives you all the HTTP transactions, for example number of transactions, status codes, error codes, top 10 HTTP requests, etc. Likewise, you can also look at network flows, and here you can see connections over time, top hosts creating traffic, top hosts receiving traffic, network traffic between hosts. Under DNS overview, you can get some DNS related data. For example, DNS query summaries, DNS requests over time, the question types, DNS client and server IPs, top 10 questions for DNS. Now next, you can also look at DHCP transactions. Now here you can see NAC and decline counts, transaction count, client counts, data transfer, message type over time. Now this is the overview dashboard. You can look at different clients that are trying to access your websites, DNS transactions, HTTP transactions, transaction types, response over time, response time percentiles, error versus successful transactions, error counts, latency, etc. What I want you to do after this is I want you to deploy Packetbeat on web server 2. With this, we've come to the end of this video. Thank you for watching. I will see you in the next one.
Hey guys, in this lecture, we'll create a 3-node Elasticsearch cluster with 2 nodes being master eligible. We'll also separate out our Kibana application onto its own instance. The communication between Elasticsearch nodes will be over SSL, and the communication between Kibana and our Elasticsearch cluster will be over HTTPS. Now, here are some steps. First, we'll create 3 Elasticsearch nodes on our GCP trial account. Then we'll also create a Kibana VM on our GCP trial account. After that, we'll install Elasticsearch on all the 3 Elasticsearch nodes and install Kibana on its own node. Then we'll generate an Elasticsearch CA and create all the certificates. This is because we'll be using self-signed certificates. If you do not want to do that, you can generate a certificate signing request and get your company's CA or a public CA to give you the certificates for your cluster. Once we've got the certificates, we'll distribute these certificates to all nodes. Then we'll configure Elasticsearch and Kibana, and finally we'll ensure Elasticsearch nodes join the Elasticsearch cluster and the Kibana node can communicate with Elasticsearch over HTTPS. So let's get started. As you guys can see, I'm inside my compute engine and on VM instances page. Here I'll click on create instance. I'll click on new VM instance from template and I'll choose ELK template and click continue. I'll change the region to US West 1. I'll keep the name as ELK1 and I'll go down to networking section, expand this and then expand networking. I'll make sure this VM is in Elasticsearch VPC and in monitoring subnet, and after that I'll click on create. Now once this VM is created, I can create 2 more. Once I've got the 3 Elasticsearch instances created, I'll click on the create instance button again to finally create my Kibana instance. I'll click on VM instance from template and again use my ELK template and click continue. Here I'll change the name to Kibana, change the region again, go down to networking, make sure it's under monitoring subnet and click create. Finally, I've got my 3 Elasticsearch instances and my Kibana instance ready. Next, we'll test connectivity to all of them. So what I'll do is I'll first click on these 3 lines to change the column display. I don't want zones because I know all the zones they're in. I don't want recommendations in use by, and I'll click OK. Now I'll change the size of my browser window to bring up my terminal. So now I've got my GCP trial account on the left hand side and my terminal for Mac on my right hand side, and I'll check the connectivity from my Mac to the external IP address of my GCP instances. So I'll type in SSH space labit at, and then I'll copy the external IP and paste and hit enter, hit yes. I'm able to log into the first instance. Then I'll open up a new tab with profile basic. Here I'll type in SSH labit at, then the external IP of the second instance and hit enter, yes. Same thing, I'll add another tab, SSH labit at, and then I'll copy the IP address of the next instance, yes. And finally I'll copy the external IP of my Kibana instance, open up a new tab and do SSH labit at and paste it here. Click yes, and now I'm able to connect to all of them. So I'll minimize this and we'll start configuring our instances. So first we'll have to install Elasticsearch on all our 3 Elasticsearch instances. So please go ahead and you can follow the same steps that I've showed you in a single node deployment. Just don't configure the elasticsearch.yaml yet. Just install it and come back, and I'll do the same on these instances. After you have installed Elasticsearch on all the 3 Elasticsearch nodes, it's time to install Kibana on the Kibana node. I've already installed the public signing key and saved the directory definition. So all we need to do on this instance is sudo apt-get update and sudo apt-get install Kibana and hit enter. Now as you can see, Kibana got successfully installed on this machine. After Kibana is installed, what I'll do is I'll move on to the Visual Studio terminal so I can reference my notes while I'm configuring the services. Here on screen, I've got my Visual Studio Code window open with my notes on the left hand side and the terminal on the right hand side. And up top, I've used this plus icon to create 4 tabs, each into my individual node on the GCP account. So first, we'll start configuring the ELK1 machine. So here, I'll do sudo vi/etc/elasticsearch/elasticsearch.yaml. And I'll hit enter. I'll go into insert, and the first thing I need to do is I need to set up a name for my cluster. This will have to be same across all my Elasticsearch nodes. I'll name it demo_elk. Next, I'll give a name to this node. I will call this node elk1. We can keep the path to data and log directory same. That's fine. Next, I'll go into network and I'll change the network.host value to 0.0.0.0. Now next I'll uncomment http.port. And next, we'll have to specify the seed hosts for our cluster. These are the initial hosts which will form our cluster. Here, I'll put in the private IP address of all my Elasticsearch nodes. So if I go into my GCP console, the private IPs are 192.168.1.6, 7 and 8. So that's what will go in here. After we provided seed hosts, we need to provide which nodes can be master eligible. We want ELK1 and ELK2 to be master eligible. So that's what will go in here. I'll type in ELK1 and ELK2. Now that's all for this file for now. I can save it, WQ exclamation mark. Now once I've done that, what I'll need to do is I'll need to go to user, share, Elasticsearch and bin. Now once inside bin, we can do an ls and you will see there's a utility called Elasticsearch-cert-util. We will use that to first create a CA and then generate some certificates for our application. These certificates will be self-signed certificates. So let's get started. First, we have to generate a CA. To do that, we'll type in sudo /elasticsearch-cert-util, and to generate a CA, the command is CA, and we'll hit enter. We can keep the defaults and no password for the CA. This file .p12 is in path user share Elasticsearch. So I'll do an ls here to make sure this file is there. There it is. Now CA files is generated. We need to now generate the SSL certificates to be used by Elasticsearch nodes. So what we'll do is we'll go back into bin again and I'll hit up arrow to go to my Elasticsearch utility command, remove CA, and this time I will type in cert because I want to generate certificates, and to generate the certificates I have to provide a CA. I'll type in --CA and we'll copy the name of our CAP12 file and put it here, and because the file is in its default location, we do not have to provide a fully qualified path to it, and I'll hit enter. When it asks for a password for CA, we didn't provide one when we were generating the CA, so it's fine, we can hit enter. Now we can accept defaults for the certificate file as well, no password. Now this file should also be in user share Elasticsearch. So I'll go into that directory and do an ls, and this is our Elasticsearch certificate file. Now this is for the SSL. So if we go back to our PowerPoint, this is for the communication between the Elasticsearch nodes. For kibana communication, we need to create an HTTP certificate. Now in order to do that, we can cd into bin. This time I'll type in sudo /elasticsearch-cert-util, and here I will type in HTTP to generate the HTTP certificates. I don't want to generate a CSR, so I'll type in no. This is the option you use when you're using a third-party CA, for example your company's CA or a public CA, but since we're using the self-signed certificates, I'll type in no and hit enter. Yes, we want to use an existing CA, so I'll type in yes. Next, it wants the path to my CA's P12 file, so I'll copy the path, which is user share Elasticsearch. I'll copy it here, is Elasticsearch ca.p12, so I'll copy that here as well and I'll hit enter. Now there's no password for this CA file. Now next it asks me how long I want the certificates to be valid. Now I want the default, so I'll keep it as 5 years. Next it asks if you want to generate a certificate per node. In a production setup you might, so you'll go yes here, but for now I'll click on no and hit enter. Now it wants the host names for all the nodes, or we can provide wildcards. Now I'll show you something. For a minute I'll go to another instance. Now here we'll do sudo vi/etc/hosts to open up my host file. Now all the GCP instances have an internal DNS which looks like this. So first the host name that you provided during setup, the region they're in, .c, and then the project they're in, and then .internal. What we'll do is we'll generate a certificate using star.internal. So I'll type in star to cover everything from host name, .region, .project, and then I'll type in internal and hit enter, and then hit enter again, and I'll go yes, that's correct. Now it wants us to provide the IP addresses of all my nodes, so I'll do that. 192.168.1.6, then 192.168.1.7, 192.168.1.8. Please note, obviously this will be different for you, so what you'll have to do is you'll have to go to your GCP console and look at the internal IPs and provide these in this place. If these are not correct, your nodes will not join the cluster. So I'll type in enter and enter again to get out. Yes, these are correct. Now I don't want to change any options, so I'll click on no. I don't want to provide any password, so I'll click on enter and I'll accept all the defaults. And this should create a zip file in my user share Elasticsearch location. So let's go one level above and click clear and do an ls. So now we've generated one CA file, one certificate for Elasticsearch nodes, and a zip file. Now let's see what's inside the zip file. So I'll type in unzip elasticsearch.zip. It can't find unzip, so that's an easy fix. I'll type in sudo apt-get install unzip. Now once unzip is installed, we'll do the same command and attach sudo to it. Clear out of this, do an ls. Now we need to go inside this folder, so I'll do cd elasticsearch and hit ls. It has the http.p12 file. Now let's go one level above and do an ls again. There was also a kibana folder, so let's go into there and do an ls. There's an elasticsearch ca.pem file. So there's an http.p12 file and a ca.pem file that was created in this zip. So now what we'll do is we'll move all these relevant files into my /temp directory so I can download all of these and then distribute them across the nodes. So I'll first go one level above, clear, do an ls. I'll do a copy elastic-certificates to copy the certificate file first to /tmp, and I'll have to add a sudo. Now next I need to copy my CA file, so elastic stack ca.p12 /tmp/ and next I need to do a sudo copy elasticsearch / the http file inside the elasticsearch folder into temp as well, and finally I need to do a sudo copy kibana and the elasticsearch ca.pem file inside that kibana folder to /tmp. Now once I've done that, I need to go inside the /tmp folder, do an ls, and what I'll do is I'll do a chmod and give full permissions to everyone on these files. So elastic star, and I'll do it using sudo, and finally sudo chmod 777. I'll do that for my http/p12 file. Do an ls -l to make sure that's done. It looks like it is. Now before we download these, we'll move the relevant certificate files for this particular node into the config directory. So let's go into etc/elasticsearch. So I'll type in sudo su. So first we'll go into cd etc elasticsearch. Here we'll create a directory called certs. Once that's done, we'll copy the SSL certificate for our Elasticsearch, which is this certificate in user share Elasticsearch, into this certs folder. So copy /user/share/elasticsearch, and the certificate is elastic certificates.p12, and we'll copy this certificate inside the certs folder. So certs/, we'll hit enter. Then let's do a cd into this certs folder. Make sure the certificate's been copied properly. That's done. Now what we have to do is let's go one level above. Here we'll again edit our elasticsearch.yaml file. So I'll do a vi elasticsearch.yaml, and inside this file we'll have to go right down to security, and under security we'll copy some security settings from my notes. So xpack security enabled true enables the xpack security transport SSL enabled true enables the SSL on the transport. We use the SSL verification mode as certificate, and we make sure that it's mandatory for the clients to be authenticated. And finally we'll have to provide the key store and trust store part for our elastic certificate.people file, which we just copied into our certs folder inside the Elasticsearch config directory. But before we do that, because we moved the path into the certs folder, we have to provide the fqdn of that path. So we'll type in /etc/elasticsearch/certs/elastic certificates.p12. We copy that and paste it here as well, and now we can copy all these settings, paste them here. Now before we move on, we also have to enable HTTPS communication on our cluster. For that we will have to first enable HTTP on our cluster, and then we have to provide a path to the http.p12 file. So as we've done earlier, I'll provided the fqdn because we've changed the path. So etc elasticsearch/certs/http.p12, and copy these two settings towards the bottom of my elasticsearch.yaml file, and now I can save this file. Now once we've done that, I'll copy this file to my temp folder as well, and again I'll do a chmod 777 on my elasticsearch.yaml file inside temp, not this one, and hit enter. And next let's copy our http certificate into the certs directory. So copy /usr/share/elasticsearch/http.p12 into etc elasticsearch certs, and let's move into the certs folder to make sure this file's there. Now let's move back to our GCP console window to download all these files. Now here on the console for GCP, I'll click on SSH next to my ELK1 instance. This will open up the SSH for this instance in a new browser tab. Now once the SSH connection is done, click on the settings button on top right and click on download file, and from here give it the fqdn, so /temp/elasticcertificates.p12 and click on download. We've downloaded the first certificate. Now next we have to download our http.p12 file, so /temp/http.p12. let's download that. Once that's done, click on the download file again. This time we'll be downloading the .pem file. So to get the name, I'll go into my temp directory, do an ls, and get the name of my .pem file here, and I've downloaded that. Now next we need to download our elasticsearch.yaml file, so I'll click on download file and /temp/elasticsearch.yml, and I'll click download. Now once that's done, I can close this SSH tab and open up a new tab to my ELK2. Now once the SSH to ELK2 is open, we'll click on the settings button again. We'll click on upload file and we'll go to the location where we've downloaded the certificates, and the first file I want is the Elasticsearch certificate, and I'll click open, and this will upload this file to home/labittraining3. And the next file I want here is the http file, so I'll click on upload again and upload the http.p12 to the same location, and finally I'll upload my elasticsearch.yaml, so this file. Now once we've done that, we have to upload these three files to the third Elasticsearch instance as well, so I'm going to do that now. Now once you've uploaded the files to ELK3, we have to go to the Kibana instance, do the same thing, but this time we just have to upload the Elasticsearch ca.pem file. So I'll click on the settings button, click upload file, and the .pem file for Elasticsearch CA, and I'll click on open. Now once you've uploaded all these files, they've all been uploaded to the home directory of the Labit training user or your individual user on your Linux machines. We have to copy them into the correct path. So first let's go to ELK2. Here let's first move on to home/labittraining3, and you can see we've got an elasticsearch.yaml file and two certificates files. So first let's do sudo su to become root, then we'll go inside our Elasticsearch directory. Here we'll create a new directory called certs. We'll copy our certificates into this new directory, so http.p12 into certs slash, and next is the Elasticsearch certificate, so elastic certificate.p12 into certs. Now let's go into the certs directory to make sure they've been copied and do an ls here. That's fine. Now we need to replace our existing elasticsearch.yaml file with the new file we've just copied over. So copy /home/labittraining3/elasticsearch.yaml into etc/elasticsearch, and let's go one level above and do an ls-l, and here we'll have to change a few settings inside this elasticsearch.yaml file. So sudo nano elasticsearch.yaml, we'll have to go down to our node.name and we'll have to change this to elk2-2, and that should be it. Now it looks like I've made a typo in node.name. We need this to be elk dash the node number, so 1, 2 or 3. So let me just double check what I've done on elk1. So here I'm on my elk1, so I'll go to etc elasticsearch and I'll do a nano on elasticsearch.yaml, and I'll change this to -1 as well, and I'll save this. So now that we've corrected that, let's save this file as well and move on to ELK3. So we have to do the same things. So sudo copy /home/labittraining3/http./elasticsearch.yaml to /etc/elasticsearch. Now I've created the folder and copied all the right certificates into its path. Now what we can do is we can do a nano on our elasticsearch.yaml file and we can change the node name. Now we can save this file. Now let's move on to our Kibana instance. So on Kibana, there was just one file. So home labittraining3. If I do an ls, there's only one elasticsearch ca.pem. So we'll do a sudo su. Now let's go to etc/kibana, make a new directory called certs here. and copy the Elasticsearch ca.pem file from our Label training directory to search. And now let's do a nano on kibana.yaml. Here, the first thing we have to do is we have to uncomment server.port. Then we have to change the server.host to 0.0.0.0. And here, where it says server public base URL, we have to provide the URL that this Kibana server is going to run on. Now, we will not do HTTPS for our Kibana's GUI interface. So what I'll do is I'll type in http:// I'll go to VM instances, copy the internal IP of my Kibana instance, paste it here, and we've configured Kibana to run on 5601, so I'll type that. Now once we've done that, we first have to specify our server name for Kibana, so I'll uncomment that and I'll type in demo Kibana here. And here we need to specify all the Elasticsearch instances for our queries. So basically, if you just want your queries to run on a single Elasticsearch instance, you'll have to specify the IP address of that instance. But because we want them to run on all our instances, I'm going to supply all the Elasticsearch instances here. So I'll go back to my notes and I'll copy this string from here and I'll remove this and I'll paste it and I'll correct the IP addresses. Now once I've done that, the next thing we have to do is we have to provide the path of our .pem file. To do that, we have to go to elasticsearch.ssl.certificate authorities and I'll uncomment that. And here I'll have to supply the path to my ca.pem file. So I'll remove all that, type in etc/kibana/search/ the name of our Elasticsearch ca.pem file /elasticsearch ca.pem. And once I've done that, I can for now save this file. Now it's time to start our Elasticsearch cluster. So now I'll go to my ELK1 machine. I'll type in systemctl start Elasticsearch and then I'll go to my ELK2 machine. Get out of here. Systemctl start Elasticsearch. I'll have to type sudo in front and then I'll go to my third machine, do the same thing. So sudo systemctl start Elasticsearch and hit enter. And let's see if the first Elasticsearch instance came up fine. Okay, seems like there was an issue. So to troubleshoot any issues, we can use general ctl -f -u and then the service name. So let's have a look. Okay, so it's failed to start the service. Another place you can go looking is under var log Elasticsearch, and if you do an ls, there'll be a .log file. So let's do a cat on that. It says access denied to the certificate file. So let's go back to our Elasticsearch folder. Let me clear everything, and here let's do an ls -l. Our certificate folder is root Elasticsearch. Let's go inside there and do an ls -l. Our Elasticsearch certificate has permissions rw and then nothing for the group. Now we might need to change this, so we'll do chmod, and for now I'm just going to type 777 and Elasticsearch certificate.p12, and I'll do the same thing for my HTTP certificate. Now for a production deployment, you might need to look at the permissions on this certificate, but for now let's just try and start this service with these permissions. Now it looks like it started fine this time, so let's do a systemctl status Elasticsearch. Now once that's done, we can go to the other instance and do cd etc Elasticsearch. Let's do sudo su. Here let's do etc Elasticsearch and then ls -l and look at the certs folder, and let's go inside that and let's look at the permissions on the certificate. Now let's look at the status on this machine. So this one is running. Let's have a look at the status on the third machine. So as you can see, if there's a permissions issue, your service might not come up. And if I go back to my first instance, all you have to do is when you run into any trouble starting up this Elasticsearch service, you can go to var log Elasticsearch to an ls and look at this file, and as I've shown previously, it will give you a hint of where the error is. Now for now, I've also shown you how to change permissions on various files to sort out any issues. Now as you can see, with a permission of 755, this certificate loaded correctly. So probably what we have to do is go to etc Elasticsearch and go into certs, change the permissions to 755 on this Elasticsearch certificate as well, and let's try and do the same thing for our HTTP p12 certificate, and let's try to restart this service. Now let's do a systemctl status Elasticsearch. It's running, so let's now clear out. Now next we have to generate the credentials for our Elasticsearch cluster. So we go user share Elasticsearch and bin, and inside bin, if I do an ls, there is a setup passwords file. So we'll do /elasticsearch setup passwords, and I'm going to do auto generate all my passwords, and I'll go yes, and it has generated the password for this cluster for me. I'll copy these out into a file. So I've got these. And now, before I do anything, I need to go to my kibana instance and then go to my kibana.yaml file. I'll do sudo su kibana file, and here I'll nano kibana.yaml, and in this file I'll provide the credentials for my kibana system user. So this way we'll use password authentication for our kibana to communicate with Elasticsearch. I'll copy this and I'll save this file. Let's just start Kibana. Let's do a status on this service. It's active. Now what we can do is let's go back to our Elasticsearch instance ELK1 and let's get the status of this cluster to make sure all three nodes have connected to this cluster. So I'll go to my nodes, copy the curl command and add the username and password for Elastic user to this command. So -u Elastic, and then provide the password for this user and space, and I'll hit enter and change the HTTP to HTTPS. Now if you get this error when you try and connect through curl that there is a self-signed certificate in certificate chain, all you have to do is you have to tell curl to ignore the self-signed certificate. So we'll go right at top, right after curl, and put in -k and hit enter, and here you can see that our cluster has three nodes. It's called demo ELK and the status of this cluster is green. Now this is a positive response, so what we'll do is we'll copy the public IP address of our Kibana instance and see if we can get to the Kibana UI using this 5601, and the Kibana UI is loaded. So what we'll do next is we'll try and see if we can log in using the Elastic user. So I'll copy the password, type in Elastic and provided the password, but never here, and I'll click explore on my own. So as you can see, our installation was successful. This is how you can create a multi-node ELK cluster. With this, we've come to the end of this lecture. Thank you for watching. I will see you in the next one. Bye. Hey guys, Elastic.co, the parent company for Elasticsearch, has recently announced general availability of Elasticsearch version 8.x. This version has some breaking changes and the installation steps are also a bit different. So let's have a look at these now. Here on the screen, I've got the What's New in 8.0 page opened up from Elasticsearch documentation. First of all, 8.0 introduces several breaking changes to Elasticsearch REST APIs. But what they've done is they've allowed for 7.x compatibility, which should give you enough time to prepare for an upgrade. Next, security features are enabled and configured by default. So when you install Elasticsearch, it should already create some self-signed certificates and include some settings for security in your Elasticsearch.yaml file. After that is security on system indices. In version 8.0, even the Elastic superuser does not have native access to system indices. To provide access to system indices, you need to configure allow underscore restricted underscore indices permission to true for a particular user. Now, after that, there are some improvements in search, storage, indexing, and natural language processing. Next, let's have a look at the release notes. Now, on the release note page, you will see some known issues, which is basically on certain Linux platforms, the Elastic user password and the Kibana enrollment token is not generated automatically, but it gives you a list of commands that you can run to generate these after the installation. Then it lists all the breaking changes in this version. Now, if you're already supporting a production cluster, I would recommend you to go and look at each of these changes to make sure there are no surprises after the upgrade. With this, we can move on to installing Elasticsearch 8.0 onto our VMs. Now I'm inside my GCP platform and VM instances, and I've got an ELK machine where we will install Elasticsearch 8.0. So I'll copy the external IP address of this machine, and then on my Visual Studio Code, I've got some steps on the left hand side and my terminal on the right hand side. So I'll type in SSH space labit at and then the external IP address, and I'll click enter. Here I'll type in yes, and once inside the machine, I will type in sudo apt-get update to update the system. Then I'll clear out of this and type in sudo apt-get install wget to install wget on this machine. Once wget is installed, we can start with the installation of Elkstack. So first, I will download and install the public signing key. So I'll copy the command and paste it inside my terminal and hit enter. Now what I'll do is I will include all these commands with the description of this video so you guys can have access to these commands as well. Next, we will install apt transport https package. After that, I'll clear my screen, and next we will save the directory definition. One important thing to note is that where it says 8.x, for 7.x packages, in this place it will say 7.x. So there's nothing major in the URL, just a small change from 7 to 8. And paste it here, and this should download the Elasticsearch 8.x repository definitions onto this machine. Now next, I'm ready to install my ELK stack on this machine, so I'll copy this command and I'll paste it here and I'll hit enter. Now during the installation, you will see some information pop up under security auto configuration information. Under this heading, you will see the built-in super user Elastic's password. So under this line, the generated password for Elastic built-in super user is this. You need to save this password because we will use this later on. So I will go down in my notes. I will save it here. Now after everything is installed, I will clear out of my screen. Now from here, we will first configure our Elasticsearch. So sudo vi /etc/elasticsearch/elasticsearch.yaml. Now on this file, first we will change the cluster name. I will call it demo elk. Then I will change the node name, which I will call elk1. Next, I will go down to network.host and change the value from the default value to 0.0.0.0. After that, I'll uncomment the port, but I'll leave it as default 9200. Since this is a single node cluster, we do not need to do anything under discovery. Up until http.port, the configuration was similar to what we had to do for 7.x. From 8.x onwards, you'll start seeing a section called Begin Security Auto Configuration in the Elasticsearch.yaml file. This is because, as I told you earlier, Elasticsearch now by default includes some security options. So if you can see here, expect security is enabled by default. Security enrollment is also enabled by default. It has created a key store path for HTTP communication under certs, and the file is http.p12. It has also created a mutual authentication key store and trust store. Now we'll leave all the settings as default and we'll save this. Now here, if I go into my Elasticsearch directory, so sudo su, and if I do an ls here, you will see there is a directory called certs, and if I go into certs and do an ls, you will see the ca cert, which is http_ca.crt, the transport certificate under transport.p12, and the http certificate under http.p12. Now we can start the Elasticsearch service. So systemctl start Elasticsearch. Now once the service has started, if I try and do a curl, just like I used to do for 7.x system, so curl -x get http localhost port 9200 underscore cluster and health pretty, and if I do an enter here, I'll get an error because the cluster is actually on HTTPS, so I will need to first change from HTTP to HTTPS. But even when I run this, I should get an error. So it says SSL certificate problem, self-signed certificates in the certificate chain. To overcome this, I'll hit the up arrow, and just before xget, I will type in -k and hit enter. And this time I've got the missing authentication credentials. Now we have not yet set up the built-in user passwords on this machine, but by default Elastic has set up the Elastic user's password for us. So I will copy this password and I will hit the up arrow, and after the -k option, which was to ignore the self-signed certificates, I will type in -u space elastic and then colon, and then I will provide the password for Elastic user. And now if I hit enter, I should get the cluster health. So as you can see, the status of cluster is green. So with the self-signed certificates, you need to use -k option, and by default now you have to use Elastic user to get the cluster health for the first time. Once you've done that, let's clear out of screen. Now before we configure Kibana, we have to set up the password for Kibana underscore system user. So first I will go into USR, share, Elasticsearch, bin, and I'll do an ls. From this bin, I will use the Elasticsearch setup passwords utility. From here, I will use the Elasticsearch reset password utility. So I will type in /Elasticsearch reset password, and I will type in -u to tell the system which password I want to reset, and I will type in kibana underscore system, and hit enter. And I will type in Y here, and I've got the password for my kibana underscore system user. So I will copy this and I will paste this here as well. Now once I've done that, I can now configure kibana. So sudo vi etc kibana kibana.yaml, and again I will uncomment server.port, uncomment server.host, and change from localhost to 0000. And next I will uncomment server.public base URL, and here I will type in http, and now we need the internal IP address of our kibana instance. So I'll copy the internal IP, paste it here, and provide the port. Then we can configure the server.name, and here I'll type in demo-kibana. Next we'll go down to system Elasticsearch, and under there I will provide the value for Elasticsearch username, which is kibana underscore system by default, and then we'll have to provide the password which we just generated. So I'll copy this here and paste it. And now if you go down under system Elasticsearch optional, because we're using self-signed certificates for this demo, I will uncomment elasticsearch.ssl verification mode and change the value from full to none. This will ignore any warnings for self-signed certificates. Now another thing to note is that from version 8.x onwards, Kibana by default logs its logs onto a file. In some previous versions, the logs for Kibana by default were only available on standard output. So this is also a nice change. Now let's save this file and let's start Kibana. So sudo systemctl start Kibana. Now let's get the status. It's active and running. So let's go back to our instance, copy the public IP address, paste it into a browser, and then provide the port 5601. Now I'm getting a Kibana server is not ready error. So I'll go back to my deployment, and here I'll open up my YAML file again, and I will look for errors. Now inside my kibana.yaml file, I forgot to put in the host value for Elasticsearch. For version 8, what you have to do is you have to come in here and change from HTTP to HTTPS. Now I'll save this file again and let's restart Kibana. Now once the service has restarted, let's check status. So it's active and running, and we've got the message saying HTTP server running at 00005601. So now let's go back to the browser and let me refresh it. Now we've got the login page for Kibana. So I'll type in Elastic here, and I will copy the password for my Elastic super user. Go back and put the password in and hit login. I'll click never, and we are in. So this is how you can install Elasticsearch version 8.0. The steps are a bit different from Elasticsearch version 7.x, but they're not that different. Most of the settings are same. So if you're careful, I'm pretty sure you'll be able to confidently set up your own clusters. With this, we've come to the end of this lecture. I will see you in the next one. Bye.
If you like this video, please subscribe to our YouTube channel.